Monoceros Modularity with 2 tutors today, which should be a lot of fun. And if you don't know, Monoceros is from a plugin for Grasshopper focused on wave function collapse and developed by Subdigital. So let me introduce here and have Kristýna, who's a member of Project Monoceros and an innovative architect at ICE Coral 3D CP. And Kristýna is an architect designer specialist in digital production and prototyping. The focus of her work is prototyping, creating physical materializations of digital algorithmic designs, experimental and conceptual architecture. She was also interested in interdisciplinary discussion, linking architecture, design, visual art, small-scale spatial installations, and scenography. She's a graduate of the Faculty of Architecture at Brno University of Technology, where she now contributes as an external consultant for Jerry Vitek's studio at the Institute of Experimental Architecture. Now she works in a company, ICE Coral, focused on automation and 3D printing concrete. And then we have Michaela, who's a final year student at the Department of Architecture at Academy of Fine Arts and Design in Bratislava. Main themes of her studies are large-scale architecture, modularity, discrete aggregation, and computational design. These themes she applies not only in her academical research, but also in the studio Subdigital. She's a member of the Project Monoceros development team, focused on practical implementation of Monoceros in architecture and design practice, as well as teaching Monoceros at her home department and international events. And welcome, both of you. So happy to have you and make this happen.
So thank you for
yeah. So just a reminder for everyone that's in attendance here, there's a link to Dropbox, which has some files and also the plugin. And then there's also another link for a shared Miro board that they'll be using during the webinar. Please, if you're talking in the chat, make sure you switch the chat to say everyone, otherwise you're only talking to us. And if you have questions during the webinar, please use the Q&A button. If you see where all your Zoom buttons are, there's a button called Q&A. This will help us keep track of the questions to answer them easier for you. And just a reminder that this is recorded. There is a recording of this, and that not everyone learns at the same pace. So if you feel you can't keep up, just feel free to watch and observe and go back to the recording, as we want to be able to get through all of the material today. So we can't stop all the time. Okay, thank you. And I'll give it to you.
Thank you for a great introduction. I will start by sharing screen. It's this one. Yes, you should have access to Miro, but if it doesn't work for some reason, it doesn't matter, because it's just for help, you know, to organize in these today tutorials. And you can find here links, which is this thing. Yeah, it's okay. Where you can find resources and some informations. And today programs, it will be, I will start with introduction. Also, like I would like to introduce you not only how the plugin works, but why we decided to do it like this, who we are, where you can find information, what projects we made. Because I think the 5 hours, it's quite not enough to introduce like totally completely into this problematics, because usually if we do workshops, it's like for several days. So today workshop, of course, there will be a lot of examples. Some of them will be built up from scratch. Some of them will be like reverse engineering and you know, a little bit advanced features. So it should be like a whole Monoceros, but we would like to also give you the insight of the possibilities. So in the beginning, I will talk about projects we made, concepts, and about the theory. Then Michaela will show you the interface and a totally basic example. Then I will continue with something more object design oriented. We should have we have a plan for 3 breaks, like, you know, a short one, but maybe it can change a little bit, just for you to know. Here in the mirror, you can find some pictures, what is waiting for us today. Like I said, we will start with this simple ruled projects, and to go through some surfaces, pipes, some toy stuff, and go through something more complex to the architecture. And as a headliner, there will be like housing from Michaela, which is also her diploma project. So this is the, I think, most complex project we made in Monoceros. So I hope we will have enough time, but I think we are like quite flexible. I will start with our website, where you're gonna find plenty of information. Also, why Monoceros is called Monoceros, because it's a legendary animal, as the whole plugin is legendary. And it's the Monoceros is made from parts, like it's made up from a piece of elephant, boar, and so on. So you can see the discrete connection between those. You can read a lot if you want after. There is also link for Monoceros Basic. Maybe some of you already seen something or downloaded. You can download it and start from Food for Rhino. And a lot of features are same as with Monoceros Pro, what we will teach today. But it's a little bit simple. It's a little bit more simple, and we will like discuss later. But just don't mix it up. This is Monoceros Basic, and we gave you Monoceros Pro, which has more features, more possibilities, and it's not free. But for Monoceros Basic, you can find free manual and also source code and etc. I will start with this book we made. Yes, everything started like 2 years ago, when our software programmer Jan Todt came up with idea that he found out one great algorithm. It's called the wave function collapse. It's just the name came from quantum physics, but it's just inspirational. It's these algorithms came up from a game industry. They use it for generating procedural maps. And we are not the only one who applied into some design. On the right side, you can see the game. You can download it from. Okay, there is some. Could you send me the mirror board? Okay, they will. Yeah, you can download this a game from Steam and play it, and it's based on the same algorithm. There is also some plugins for Houdini. So it also gave us like sign that this algorithm makes sense to use. And then I would like to like explain you how the engine works, because I think it's quite important. I think it's quite important if you understand what is going on inside the black boxes. And I will show it to you in this like super simple example. This one, or this book, you can also open it, so you can read it, and but you can follow my screen. It's okay. So this is I think the most simple example we created. The logic starts with modules. It's like a discrete unit. It doesn't matter if it's number or piece of land or stick or house. It's just a discrete unit. And you have to give it some rules, like on sides, how it should behave, to which other components it should connect, and etc. And then you have some envelope or some space which you want to solve, like game Sudoku or something like that. And you start with the initial state where everything, where all the modules are allowed. And then you start to constraints, or you start to solving this puzzle. And so the first step is that you can do it randomly or intentionally. You put one random module into one random slot. So it's, for example, this. You put the coast here, and then the propagation starts. The propagation starts regarding on rules. So if I put coast here, I take a look to the rule set, and I see that on the left there can be only coast, on the right side only coast, here on land, here sea. So it's quite simple, because then the propagation starts, and it's sure and visible which components should have. And we have quite a fast solution. Here we have the same example, but the observation, the first observation is different. And then you can see that here it's not so clear. So we need another observation. Well, I'm explaining this to you. Now it looks like really, really simple and obvious, but we will get into it like later, that it's really important to make a good rule set. Because, for example, if some of these modules don't have complete rules, so it won't be possible to solve this puzzle. So this is basically the engine, the wave function collapse algorithm. Yeah, there are some other examples, like a little bit more complex, or sometimes, and it's happening quite often, that it can be a contradiction, that there is no suitable module you can put into your puzzle. So you have to be careful what you are doing, actually. And so, as maybe you already see, there is three important concepts. We will talk about them a lot today. So one thing is the single module, the little discrete unit, which can be like pipe or whatever geometry you wish. Then we have slot. It's like a cube. It's not necessary to be regular. It can be like another. It can have different sizes, but cube is the most simple. You can make a rigid box or envelope, whatever you wish. We will show it to you later. And the set of rules. This is I think, one of the main differences between the Monoceros Pro and Monoceros Basic. These rules, the logic is quite different. So if you want to experiment with both of them, so pay attention about this. Yeah, here's more information basically about the Monoceros Basic. We can read it. Yes, examples. And we call it research. It was like totally in the beginning when we had only like one component for wave function collapse and a big spaghetti monster all around it. And we had to put the data from Excel file. And we were just trying if it does something, you know. So these pipes are like representations for rules. And we were creating some like totally basic examples and testing if it does something and if it makes sense. And we realized, okay, it makes something, it makes some patterns, sometimes colorful patterns. So it makes sense. And when we started to apply it, and actually, it doesn't matter on which scale you are, if it's like a lamp or house or urbanism, because it's still about unit and the relationships. This project, it's my favorite one, and I will show you this today from scratch. I also try to make it like in a real life. I haven't finished it, but one day or in the next life, I will finish it. So we will make it together online. And I like this project because it's like super simple, but quite like complex. Well, I like simple simple applications. Well, there is another quite similar approach. Yeah, there you can see that the modules can be extended or can be drawn in more cubes, you know, so it's not necessary to have module only in one cube. Then this is also a funny project because it contains only from 2 components, actually. I don't count the rotations, but the guy made quite complex structures. It should be something like kindergarten. This is project of Michaela. She will talk about it a lot like later. It's a really complex, insane project with a lot of things, a lot of Grasshopper, and I think you will love it. And also girls made urbanism, so also urbanism is made, and I was quite surprised at how complex it is because it was used like before Monoceros. They made it like I don't know how they made it actually. Also, this is for one diploma project from Angewandte. Jiří made a whole city with a few components. So it is possible to really work with a lot of geometries and really big sites. These are some school projects from Prague University. And also we like fabrication, so sometimes we try to make something in a real life. It was also really in the beginning because one of the aims we would like to do it. It's not only make it in a virtual world, but make it real. So very often question is why we work only in a grid, in a regular grid. And one of the arguments are that we would like to use like prefabricated pieces, for example, like this, or I don't know, brick or something what is already made, something regular, and then make something very complex. So we created this. It's like a landscape representation of possibilities, rules. There are like 3 types of elements. One is metal, second is plexiglass, and the third one is wood. And each of them works differently and behaves differently. But it was just an experiment, and we have nice renders. And yeah, and this project, it's not about only the plugin itself, but it's all about connecting projects, connecting people. We also make a lot of differently oriented workshops. So this is one of them. I will show you this. Yeah, and something also about they introduced us, Michaela and me, but really important people are like Jan Todt. He is the system programmer, and he came up with the idea of wave function collapse, and he coded the engine, because not me, also not Michaela, we are like programmers on a level of Grasshopper, you know, but we are not able.
We are architects, basically.
Yeah, we are architects and designers. So if you have some questions about the code, don't ask us, please. And Jan Vernetsky, maybe some of you already know him. He's quite famous. And he already made before several plugins for Grasshopper, like Boids and other one I don't remember, but he made a lot of work on Monoceros, and he created the components and the logic. So these two guys are like so super important in this project. And just a little an intro, we made also some workshops, and this was funny because we tried to create it more like in a real life, more in hand. So we fabricated all of those components, and we tried like compare results of Monoceros and results what people, and also we had there some kindergartens and some children, and so it was quite funny that you design something in computer, make some rules, and then you let the kids to play with it in a real life. So also it can be one of the approaches. And for example, this project will show you, Michaela, later how to code it, how to make it. And yeah, and the fabrication, I'm really interested in it, like pull out or, you know, when you design something in a computer, and it's, I think for me, it's super interesting to pull it out and fabricate it in real life. So today my project will be more like design oriented, and I would like to show you that I am always trying to connect projects and put them like in real life. And as Michael mentioned, now I work in a 3D print and in a company focused on 3D printing from concrete, and this is like super basic rule set and super basic components. But we used Monoceros for creating this green wall. And yeah, maybe some tools will be more efficient, I don't know, but we use it. You can draw the pattern, and yeah. So this is one example of project, and the second one, it's for me, it's like a sci-fi, because when the war at Ukraine started, the company was like, okay, we should help something, and hey, architects, do something, like design something. I was like, wow, okay, something more military. I don't know nothing about military, like you know, my education about these things came up from Hollywood movies. But you know, my agenda is for a long time the discrete design and modularity. So we created this modular system. It was just a sketch, but there was like a really great feedback, and also like military, also from Ukraine, they were like really interested in. This is just sketches. We are now already much further, and this photo is actually from Ukraine, and they are testing it. So I think for me it was like totally sci-fi that you know, we are playing with some Grasshopper tools and so on, and we are making crazy cities and our diploma projects, and we are debating about it, and now it's standing in Ukraine. And yeah, so this is the point that I would like to show you, that you can connect it with like insane combinations. Well, and you know, the system is quite like almost stupid. But as I said, we already developed it a little bit. Well, I think what I want to say, we have 30 minutes. Maybe now we can switch to like more practical things, like how it works. Michaela, what do you think?
Yeah, okay, sure.
And yeah, you will show like how it works and some basic example. I think it will be like half an hour, and then we can make like short break, or we will see. It's okay? Or yeah, I don't know if there was any questions.
Some like this because we have like 40 minutes left.
Okay, I think your microphone is cutting.
Yes, I
Is it?
can't hear you.
Really? It was
Now
working.
I can hear you.
Now you can hear me.
It's strange. It was working on the test and everything. Every time you start doing something live, like starts to not work. Anyways, I hope everyone can hear me right now.
Now, yes.
Okay, perfect. Yeah, I will share my screen instead. Okay, so as we promised, now I will actually get into Rhino, and it's here. I will actually get to Rhino and like start to show like what is what, and what's also for some people who already used the free, like the version from TUTOR Rhino. There are some differences, and you will see shortly. I will just open a new file. Firstly, I will just start everything. I think we don't need it right now. So right now I don't have installed the basic version of Monoceros because it's finished, and we are so over it. So the main difference is, if you could see from TUTOR Rhino, the colors changed. the most apparent difference is that now we are black and white. It's because when you install Monoceros, and also you have Monoceros Pro, I have no idea how to hide my panel, and it's blocking my view on. Never mind. Okay, I will try to. Yeah. So it's black and white now, and there are so many more components. But also the main difference between the regular one and the Pro version is that you need to make a lot more Grasshopper around. And it's because we were trying to make it cleaner. Like we were trying to get rid of the stuff which you can already. The sound is poor now. Oh no.
For me, it's sounding fine. I don't know. Maybe where's your microphone? Is it near your computer?
It's right in front of me.
Maybe stay closer to it, but for me, it was sounding okay.
Maybe if anything will fail, I will connect my trusty microphone with a sock on, and I will try to do that. Like, let me know. I will try to work with that. Maybe like this. I have it the closest possible, and I hope everyone can hear me now.
Yeah, I think it's fine.
Yeah. No, like, make me notice if it's gonna be some problem. So where was I? That we were trying to clean the stuff around, so we don't have any duplicate operation, like interfering with the normal like Grasshopper components. So if we had like I cannot remember anything right now, but maybe if I will like start to introduce every component, something will pop in my mind. Also, Kristýna, if you think we have something, I know we purged it and then we added some new features, and let's just dive into it. So we have, first of all, like we have the parameters which are like essential for making anything in Monoceros. So first of all, we have some module which looks okay. I will also do bifocals just so you can see, and I will show the beautiful icons I never use, and fancy icons. Yeah, now we have fancy icons and bifocals, so now we all set. So we have a component called module, which is like obviously essential part of Monoceros because you are making stuff out of it. Every module has connectors, so we also need connectors which are derived from modules themselves usually, or you can create like some connectors manually, but usually in the normal use we only we derive the connectors directly from modules themselves. Then of course every module needs to have its name. So we have a name, and we need to put it somewhere, and it's called slot. So we put modules in every slot, in slots, and every time we have some algorithm, like some wave function collapse needs to fill every single slot with something. Even the module can be empty, but it always has to be something defined. It cannot be like null, zero. It always has to be something, or module called empty, or module called. And now I have like first thing, we stopped differentiating between empty module and a normal module. Now it's called just module, like compared to the free version, like you can get from Rhino, because it was not necessary to differentiate those two, and it's just a fancy name of module with no geometry now. So that's something, and so to come back, we have also some rules, as Kristýna already mentioned, and which these are just parameters. You can just internalize it, and it's very useful later. I will come back to slots. Why you can pre-solve something, and you can internalize the solved like solution, and then you can use it later, and you can change the modules itself, the geometry which is inside of the modules, and you don't need to like wait for the solution, because sometimes when you have something heavier, you don't want to like go through it again and again and edit the modules constantly. So these parameters are quite useful. But to create a module, we need to construct it, and we have all other standards. Like we can also deconstruct it. We can deduplicate them. We can rotate them. We don't have to draw all the rotations, but we can. We have something which rotates it for us. So. Let's just start with like constructing module, because that's the most basic stuff we can do right now. So we need some name, we need some box in which the module, so we need some dimensions, and we need some geometry that contains, and it's optional. Even Jan writes there, it's optional. So we can create our empty module. Module box. That's a funny thing. We can use any box in every way possible. You can create a box. You can create it just like this, and it works. But the cleanest way how to make boxes is not like reference it through, but let's try it. It can sometimes Rhino is not so precise as we would wish, and sometimes we have like right now it's probably gonna be fine. It's 5 millimeters, but also I like to have a grid snapping on, but sometimes even with the grid snapping and everything, we have 5.001 or something like that. Like we have something wrong, and it creates some problems if we have like slightly different dimensions of boxes. So I advise either create a point and create the box inside of Grasshopper itself, or just create it completely. But let's box. So oh no, not this one. Geometry. So many ways how to create boxes in Grasshopper, like 50 shades of boxes. Send on geometry. You can have a box. You need a name still. So many ways how to create names. You can write a simple panel. It's called Michaela, and you can name it anything you want. I think the problems are. I don't think it has some problems with right now with any like these or these. I usually like do these or that and numbers, but that's it. You can try if something doesn't work. You can also tell us because that's for now it's fine. So we have a module and the component is already happy. It's white, so it's happy, but it gives you Monoceros itself. It gives a lot of warnings because we are also lazy to explain everything. So we wrote it once and now it's there. Now it warns me that it doesn't have any geometry inside. So I can put some geometry inside and maybe some little roasted maybe. Oh yeah, and let's leave it like this and let's see what happens. Now it's slightly unhappy. It's working. It's counted as a module. It just warns me that it might not be intentional. Usually when I move it inside, it gets happier instantly. Yeah, now it's happy. So yeah, that's how you construct module. But the cleanest way how to create it, we have also some tools to create like slots themselves, and we work on grids, and you can make either like a homogeneous grid, which is like a grid which has it's everywhere the same. So let's demonstrate it because this is I'll just move this away because it's bothering me right now. Okay. We have like one box, and this can be actually used as my box already as it is, or we could create like lots of boxes and it would behave as slots. So like modules and slots are basically the same. We have the modules which are inside of one singular slot usually, and like a lot of slots means it's some kind of envelope for our next operations. So I can like this homogeneous grid, it works exactly as you would imagine. You can put some dimensions, and we have also something which is called diagonal. And this is quite important, and I'm gonna create it right now because it's gonna be useful through the whole process. And we just create a vector from X, Y, Z. And that's our dimensions, and we will repeat it everywhere. And I usually copy it everywhere the same way. So I will decide that I want something which is with dimensions 300 millimeters. Let's say millimeters. It could be 300, whatever. So we have a vector right now. And diagonal, if you look, it's in a format. If it's in a format of vector, so this should be right now happy, and it's so gigantic. But now I will go by like this, and I will open the other file where it makes sense actually. So we have like something which is called 30. And we can base plane, an XYZ number of items. I will say like it's 5 to 5. And we have already some space we can fill with some modules. Also, this two needs to match. So I cannot put like a module which is with dimensions. Literally, I don't know how much it is. It's 5 to a slot, which is 30, obviously. I will open already the my cheat sheet, because you can also find these files in examples on the drive I've sent you, and also it's here. The drive is here. If you want to follow me, you can, and you already have it all set. And I will just open that so we can open document, and we have our first example is gonna be plumbing. I'm gonna give you a little sneak peek, but I'm gonna build it from the scratch. And it's gonna be this one, and it's gonna be this one. So what's changed? I changed the grid from the scratch. The usual. I like to work in grid, so I can like. I don't have to measure it and have some. If I do some simple examples like that, so I already pre-made matching dimensions, grids with dimensions, and we already have the sneak peek. You can also see it in here. Is this first one? So I was here. I created a vector, which is now sized 300 times 300 times 300 millimeters. And this is what I say when I say that I copy it everywhere, because we're gonna use it multiple times. So first things first. I'm just gonna open also a new file to so I can make it from scratch, or I can make it like next downstairs the same way. That's gonna be actually useful. So as I said before, there are multiple ways how And I'm sorry for the sound. I live in the city center, and it's like this. So there are multiple ways how to create modules. You can reference it, or you can use a little help. I like to use geometry pipelines, which is like normal, usual component from Grasshopper. And you can just pick any type of geometries you want to reference, and it automatically just pops into Grasshopper, which is very helpful little magic trick. I'm like, I hope some of you might already know. So I usually start with just geometry I want and a point. So I would like to have a module here somewhere, probably here, and I will call it not mod, but I will call it module, something like this, and I'm gonna put it into the right layer. I'm gonna call it 1. And if I change now, it's happy and I have a point. So I know that I'm gonna draw a module here. So I'm gonna make a line, and this is a very complex module. And you can reference any type of geometry from also Monoceros supports points, but I'm not sure what for you would use it. But maybe you could find some applications for that, just to aggregate some points and then maybe later work with them. But so this is my point, and I like to separate these two. So I reference curves, and now it's in the same layer. I'll just turn these off. It's in the same layer, so I have one point and my curve, but I have these in 2 separate boxes, and that's because when I'm constructing a module, maybe there's some more intelligent way how to do it, but construct module, and I don't have bifocals. I have it. I'll put it here. So when I constructing module, I need some box, and the box I will create with that grid. So it's called homogeneous grid, and it needs the diagonal. It needs the point. So I have a point. So it's already here. It's too small. So diagonal, I'm gonna copy it from here, because this is useless to create it so many times. So now I have my trusty vector, and I will put it here. So now I have the module, which is the same size as my grid in Rhino, because I already prepared for you. So I have the diagonal, which is the size of the box, and now the number in this case I cannot create a module which contains like multiple boxes, and we could try it and let's see what would happen. So I need name again. It can be whatever. I will call it 1, and I will use this because it's gonna be useful later. It has some name. It has some. Oh, it's happy. Oh, because I can create multiple modules at the same time. But now, if I will look in here, it's called the same. There's gonna be eventually some kind of problem, and I'm just gonna leave it like this, because this is how to make a proper module. I thought that it's gonna explode or something. It didn't. Sometimes it just doesn't. and we need some geometry, and the geometry is this other pipeline. So I can separate it and I can have it clean. So this is my module. But if I want to create multiple modules at the same time, if I'm lazy, I can cheat a little bit, and you can just look at this. I just put multiple geometries, but let's keep it simple right now. I put all of them here in the example you already have. I have them in one layer, and they are all okay, this is bothering me, is here. You can, yeah, I'm having all the points and all the pipes I created. I have them all in here. I don't know where it's not gonna bother me, this thing. Okay, it's here. So I have them all, but how do you know which module is which if these are supposed to be separate modules? I just sort them in a complicated way. You will just look by yourself. I just put some points inside of the geometries, and then I ask in which box the geometry, because this is creating boxes, in which box this geometry is situated in, and I just call them, and then I just create them like that. But for now, we can create it's just 4 modules. We can create it like this. So we have our grid, we have our first module, and then we need to connect it to something. So actually we don't need this. We would need it if we would create multiple modules, because I am also creating names automatically, and now I have there right now multiple modules which are also rotated. So in the end, I will show you how to rotate them. I had like module 0, 2, 3. We will create these modules separately right now. So I have one, and these modules, this is the only rotation right now I have. If I would like to do all the rotations manually, I can. It's again quite not lucky, if I would call it number 2. I would need this. Monoceros is a lot about copying for me, so I just name it number 2. And now we have like 2 rotations, and if we would do it manually, we would go eventually crazy. Trust me, we tried it, because once we didn't have rotations, and it was quite a bore. So we created a rotator module rotations, and now we have a module, and we can also choose on which axis we are rotating the modules. And now it's placing somewhere randomly, and I'm gonna delete the number 2 somewhere else. I'll put it somewhere else so you can see it's just these 2, and I accidentally placed it on the same place as the rotator itself. So we have now 3 rotations, because there are no more. And we have 3 modules, which in logic of Monoceros is 3 modules. In logic of discrete, it's actually just 1 module, just rotated. So we have 1 discrete module, and we need to put it somewhere. But first, I will create also the other one, so it makes sense why. I will tell later, so I will just put it here, and I'm not happy about this, so I want to create I want to create different modules. So I want to make some like pipelines. I eventually want to create something like this. So something which can connect to each other, and this connects to each other, which I will say later. Why it can just automatically understand that this is working. So we have the second module, and I think for now it's gonna be enough. We're gonna see later, because if I will rotate also this one, we can make some nice loops, and it can just connect with each other, and it's gonna create some little stuff. So this XYZ, so we have more rotations of the second one, which is interesting, because the more complex the geometry is, like, then more rotations, depends on the stuff. And if you will toggle, some of these rotations false. So if you rotate on the axis Y, it's I never know which one it's which, but it should be, now we have 12, now we have 8. If we don't rotate it on XZ, we have only 4. So if we turn off XY, it only turns around the Z rotation. So I hope you will figure it out when you will tinker around it. So you can also, like, constrain the amount of rotations, and, like, call the ones you don't wish to have. So this one is, I'm quite happy, and maybe I just want these for now, and I don't want all the crazy ones which are, like, going into space. I'm just gonna have it like this. And so what's next? What do we need? So we need to put it somewhere, and also we will need eventually our solver. So I will just put the solver first, because it tells us what we need next. So we need slots, we need modules, which we already have, and we need some rules. And all these other things are seed and the number of attempts the solver itself is making, and the observations it has, and also I have no idea what's this, but Jan sometimes is making like some toggles just for himself, and I'm not sure. Let's turn first. Maybe it's for kangaroo, because we can later connect it. We can connect it also with the kangaroo, and I never tried it, but someone did. So we need some modules. So we already have 2 modules, and I'm gonna create some order in this chaos, and I will just have all the modules together, because just why not? So we have modules, but it's not happy. We are missing 2 essential parameters, and we need slots. So to create slots, we have again, like, so many ways. We could reference some geometry from here, or we could create the grid, as previously said. And the other one is a bit complicated. I'm gonna come back to it in a while. So I can just create a homogeneous grid again. This time I can choose how many slots I want. So again, we need a diagonal, so I'm gonna just use the same one. I'm gonna need some plane. I will just put some random point in some default layer, or just to create order. No, I will just put it in default. And I hope everyone can hear me, because I didn't check. I wasn't checking the chat so far. So I just looked into the computer. It sometimes hard to perfect. It's hard to like also talk and also like be aware that there are so many people in here. I need some base plane. I will just I could just do it like that, and I didn't have to do a point here. Okay, I shouldn't have done that. Oh no, now it should work. Now, so we have a point. So my grid is here, but we could use it as it is, but it would be quite sad. It would either choose how if place is one or the other. So we can try that, but we still don't have any rules. We don't have rules, and we also cannot connect the slots like this, but we need to create the slot. So the same way we create modules, we need to construct slots. And it's because we need, again, the box. We need names of all allowed modules, which can actually be inside of those slots. Let's just put it like this, and let's turn these off because order. So we need lists of all the names, and this is something advanced. We can also say like this module in this slot, particle slot, can appear more likely than the other, which is a little bit against the wave-function collapse algorithm, but it's very useful in some advanced stuff later. And we can, this is optional, and this is also some kind of like total count of modules. Like we can leave it blank. So we need names. So we just constructed the module, and they automatically transform themselves into itself. My mouse is slightly weird. And now it's called module, which is called one, which the name one. It has its dimensions. It has some axes and everything. And here we have like also already multiple rotations of that. So we have 1, 0, 1, 1, 1, 4, and it's because this rotator, it's deduplicating sometimes rotations which already have been created. So not always we have all the numbers in the end, because if we would rotate it like this or this, in case of this line, it would be the same. So it's just some naming. It just rotates everything and then it deduplicates. But we need to deconstruct the module we just constructed, because we need to obtain all the names we have in here, which are generated automatically. So we're gonna deduplicate them. No, don't deconstruct, not deduplicate, and deconstruct. So we construct and deconstruct all the time in here. So now we have this, and we can obtain multiple information. We can have the names. We can have the boxes themselves, in which the modules are situated. We can also bake the modules back. So if you want to just rotate, make many rotations of modules you want to later use, let's do it like this. You can then bake them, and they actually have all the geometry and all the useful information inside. Just not the geometry itself. Confused. Maybe somewhere else, but I think in the construct, I think here we could obtain all these. Somewhere it works. Yeah, it's in here it works. And the deconstruct module. Okay. So we would just unbake it because it's now not useful, and we can just leave it inside the Grasshopper. So we needed names, and you can also, is this module valid? Sometimes it's not, and sometimes it's a problem. And we can also have all the connectors, which we didn't still explain that we have some XYZ, like, okay, let's back it again because this was quite useful. Why sometimes stuff doesn't work. Yeah, no. We have fixed positions, the same as the word itself. We call the axis Y. It's on Y. We can also rotate them, and then we can change planes, and then it's somehow different. But like by default, it's the same way as the X, Y, Z, and we have also minus X, minus Z, and minus Y. So these are just, this is how it is. So it can always understand if it's rotated. It's not the same module. These rotations are creating rotations of the geometry inside. If you would rotate the module like this, I hope it works. It would also rotate the orientations, but it would be still the same module. And let's try it. Rotate this again, cleaning this. So I have, this is weird. So I have this module and it's rotated. And I don't know why I put angle. I didn't need to, but I want to do it like this. And angle should be some random. I don't know. We have this module, which is called still one. And if, however, we would rotate it, if we bake it, maybe we need to put it into module again. Yeah, the X would be still on the same position, just rotated. And if it's put, no matter how rotated you have the module inside, it still has the default XYZ, or you need to create it somehow differently. But that's not important right now. I hope you all understand. And if you have any questions, stop me, or like Kristýna, stop me, and you will see probably more chat than me. If something is not clear, let's clear this out. Again, I'm doing a lot of mess today. We have these connectors, which we will come back later, and we need to have names. So where did we need the names here? And we have a warning. We have too many branches for the module. We need to actually flatten it. So we have just a clean, or here. Let's do it here. So we have a clean list of just all the names that can be contained inside of these slots. And sometimes it's even writing us that, not now, maybe just a new update, but sometimes these slots are writing, but anyways, it's here. So we have now a slot which can contain a list of modules, and it operates only on names. And I have a weird mouse, and this is bothering me. It can accommodate 3 modules, and it knows which 3 modules it can contain. So I'm gonna anyways place it right here because I'm gonna use all the modules. So I want both of these module groups to be able to be contained in this slot. So now we have 7 modules. So we have a module, and it's not still happy. We need rules. And the rules are created the same way. My keyboard, every time, the Bluetooth keyboards. There are many ways how to construct rules, and I like the ones, the simplest, the quickest solutions. We already created some geometry. The geometry I made with purpose to on inside of the grid. I made it purposefully so it actually touches the wall. This is just a preview. We made it like that so it doesn't interfere with anything. The end of the grid is actually here, so it only like shows some preview. It's useful when we have multiple slots and we want to see many things. So it actually ends where it doesn't. Yeah, it's just a preview stuff. So we need to if we want to construct rules from connectors and not from modules, but we want to construct rules and just from connectors, we need to actually create the connectors. We have a list of connectors here, and we can say that everything can connect to everything, but it would mean that it would ignore the geometry inside. If we want it to behave according to the geometry, the quickest way is to suggest connectors from geometry. What it does, so we need again our modules. This is optional. We can make some source of target connectors, so we can eliminate some unwanted connectors which we don't want probably from this list maybe. But we will leave it as it is, and it will behave differently when this is not belonging here. This doesn't belong here. Oh, I was baking, and now I have a mess. Okay, now, so we have a module which is somewhere here. If I would put here instead of this on the number 2 some closed object, which could be like this, which doesn't go directly to the wall of the module itself, it wouldn't do much. And if I would do this, and also this, I will just put it back later. If we had like 2 indifferent, we wouldn't have any rules, because it couldn't identify any source geometry matching the target geometry, because it just doesn't have anything on the edge of the module. This works only if something is on the edge of the module and it's open geometry. So you can the same way as you can join something in Rhino itself, the same way you have to check it with the like, you cannot join 2 boxes like this, but if it would be like this, maybe my keyboard is not working. Is it? Do you think so? So you might think right now, maybe. I'm not sure. I was having some issues in this when we start to switch it up, but Oh yeah, wait for Kristýna, wait for the how many deconstructions you have to make. Maybe it's cleaner. It's cleaner for sure. I think so. So let's put the lines. I think you understand the idea that something, whatever needs to be in the edge. And since it's on the edge, it can create some source, target, and like this. So it can create some connectors. So now we have all the connectors, and some connectors are already like are saying that okay, we have some rules already. Like we have something in here. So on the plus X. Which is here, I think module 1.0, which is this one. On plus X, we have something. We have something on plus Y. I'm not sure. Oh, it's a different module. Yeah, the rotation, the rotated version, it's here. It's something on Y, and also the opposite ways. It creates a list of source and target, which is like. This is usually we have some which are shooting and some which are aim, receiving. So we can just connect these from suggested connectors, and we should be happy. And we also deduplicate some rules which are for some reason creating automatically, and we have some rules. And the rules are written in this way. So one can also connect to one. So it's this X can connect to this minus X, and so on and so on. We have now many rules. We have 15 rules out of just these two modules we drawn, and just out of all the rotations we made. And now we have some rules, and this should be happy now, and it's not. Because some connectors were not referenced by any rule. We didn't reference the connectors for stuff which is empty, and I created again. We need to analyze the connectors. Again, we already deconstructed models, and we need to check if these connectors are used. If they are used, it's fine. And the unused connectors, we need to also create some rules. Otherwise, it's not working. It cannot say that, hey, these are empty. We're just gonna ignore them, and we're just gonna say that they are indifferent. We need to explicitly say that these are indifferent. So we need to construct some rules out of the unused. And also important stuff, and I'm probably gonna slowly move into here because we need also some empty modules, because this probably might not work, but let's wait and let's do it one by one. So we need to analyze all the connectors. We have we need to deconstruct the modules. We have these. So we have the connectors. And I don't know why are we double grafting, but also our team created sometimes the module, the components themselves sometimes are suggesting like, oh, you should graft this probably. Sometimes you want to graft it, sometimes you don't want to graft it. And they are coming also like pre-grafted or pre-flattened, coming as we usually use them. But in this case, I don't think it should be, I think it should be flattened. So yeah, I'm gonna just not graft it and not graft it. I'm gonna actually flatten this. Now it should be, oh, this is the reason. Oh yeah, now it should be okay. Now it should be nice. This is nice, this is nice. Sometimes it's not as we intended, but maybe some other person who uses them. So we have 42 connectors, which is a nice number. It's our favorite. It's also our default random seed. We have some connectors, and we have some. We need to also have the modules themselves again. So we need a list of all the modules, and we need list of all the rules we just created. And now we can analyze the connector, and we have all the names and everything possible and impossible. It's usually it's written here, so we don't need it right now. But most important thing right now, if it's used, if it's unused. So if it's unused, we have it already written here. So these connectors are not used. So we need them to create some rules. That's okay. These rules, these all can connect to each other freely, because there's nothing like bothering us, there is no reason they couldn't be like next to each other. So we're gonna create again the same thing. So we're gonna construct rules, and we're gonna put it here with itself. And now we have also the rules which are indifferent to each other. Now it's getting happier. We had some problems, and we have some partial solution. And I wonder why is that? And I didn't choose the luckiest. Place how to, and also the color background. I hope everyone can see. This is partial, and something is not happy. Let's just create it like bigger. Probably right now, we also can get a lot of reports out of the solver itself. So now we get like this epic little long, like this long list of Monoceros found a partial solution, and we have a list of slots. Now, yeah, it can create, it can put either this one or other one, and it cannot decide. Sometimes it's like that, and it's probably because we have a ridiculously small homogeneous grid, and we just gonna increase it. I'm gonna make 15. Oh, it's probably too much. By set. Now it should be happier. Okay. We still have some partial solution, and we still don't know what's inside, only by text, because the last thing we need also the materialize the slots, because this is like somehow pre-solved, but it's not placing the modules themselves. It just ideologically like solves the whole cube we have. So we have like this whole cube, which I actually changed the background because this is not all right. Where is it? Appearance colors. Background should be white. Now we can see it slightly better. Okay, we have a box, and I didn't come prepared. So we need to actually physically place the stuff inside. So it's called, it's here. We need to materialize slots. So it's main, it's like the most important. We need to put we have to put the slots, modules into slots. So we put modules into slots, and it's not happy. It's not happy because we have some identical dimensions, and we have some kind of problem. And let's see what happened. We have only one point and one curve. Why is it duplicate? Anyways, sometimes it's not working, and I don't know if I'm not wasting too much time. So what? oh, it's just because now it's the partial solution and it's put on the same way. Anyways, I'm gonna move in here. So I created the same thing already. And I'm just gonna wrap this up because I'm taking so long. So we had like this and this. So it could be, it was just lines, now it's pipes, but it's the same idea. It's open pipe on the edge of the modules. If I could turn it off, it's just facing the same same thing. And don't mind the rotations because the rotator itself goes crazy. It's actually this. It places it randomly and over each other, and it doesn't matter. So we have these. I'm just gonna delete this for the sake of the final result, and then you can play with it later. So now I just reference these two, and this is just the result from the previous one. So we have 1, 2 modules. All of them are rotated, and all of them are not in the in this kind of grid, but I created grids manually. So I created this big globe, and I named it. I put it in the layer slots. I sliced it. So we have also other options how to create a lot of stuff. We can slice geometry, so it can just create multiple boxes. If I hide it, it's just inside. We have multiple ways how to fill it. So if I want to imagine there is it's like this. We have multiple ways how to slice it. We can only wrap the surface, so it can slice just the surface itself, and inside, if I hide it, inside it's empty, but I wouldn't do. It's empty. It's really empty. You can make sure yourself. You can either fill the volume only, so it's gonna look like slightly smaller, or you can do both. You can just cover it all, and this is the third option, and it goes around also the stuff, not only inside, but I had it like this, and I was happy about it. We just created some boundaries to our aggregate, which we'll later create. So I sliced it, and I deconstructed modules, and I wanted to come back to the empty and the out. I deconstructed the modules, and I constructed the slots the same way I did downstairs. So I put these boxes, which I sliced. I put it here, and I put all the names of the modules which are allowed. I have one more thing. You can create as many types of empty modules as you want, and I also created another layer around this whole globe, and I created an out module. Out module behaves strangely, but like let's put it before without it to show the result. Out module is a special kind of module which was already incorporated in the Monoceros, the basic Monoceros version. It's some boundary around the whole thing. It's some empty layer, which makes sure that you don't the aggregate doesn't go into the infinity. So so in this case, the out module, I created a boundary layer around the same slots we just created, and we don't want the out module inside. We want inside only these two modules which we created before, and I also added empty module, which I did the same way as the previous modules. I just didn't provide any geometry, and I called it empty or emp in this case. And I said, like, inside of this, I can have only all the rotations of the modules I created and empty. And these slots I created, I wrapped all the slots around the boundary layer, and I said, like, in these slots around, you can have only out module. So I'm deconstructing again the out module. I'm obtaining the name, and I'm putting it here. So this slot can only accommodate out module. But if the previous my attempt to create it right now, if it was would be like this, it wouldn't be with out module, and it wouldn't be with empty. So let's just make it, turn it off for a little while. So I created the same way the rules. I just made it a little bit cleaner than downstairs. I put all the modules into suggest modules, and I deconstructed them, and I constructed some rules, and also some rules for the indifferent sides of my module. And so I have the slots, the modules, and the rules. And now we materialize it, and now you can see I don't have any empty inside, and it's not visible because it's like it has some space itself, but I don't have any module which is named empty. So there is, like, every single grid is filled with either this or this. So that's it. But we have some problems on the boundaries. Like, we definitely didn't ask for this, but now Monoceros Pro is working like it's just boundaryless, and it's just there are no rules applied on the edges of our globe. So that's why I need my out module, and my out module is it also has the indifferent rules. So this cannot connect to indifferent for various reasons, for the obvious reasons. So if I put the out modules inside, so this and this, so I have like this protective layer which also contains some rules and some order, and now we are unhappy, and the solution is partial, and eventually we would probably find some solution. It's contradictory because it cannot find the solution if you maybe like maxed up all the attempts. Maybe it would find some solution how to aggregate these two stuff together, but sometimes we just really need empty module. So it can go around each other, these two modules. So we need some air, and we need sometimes to put some empty modules. So I just created empty modules, and now it should be happy. Yes, it is, and it found a solution, and it's celebrating. And now we have these. Everything is closed, and maybe it's even one line. Let's check it out. And you have two ways how to materialize, how to actually put it back into Rhino. You can either bake this or bake just put the geometry inside. The difference is, Kristýna will show it in the later example. If you do this, if you bake just the geometry, it doesn't have any properties. It's just plain geometry, and you cannot do anything with it. Like it just behaves like a normal geometry as if you copied it. But if you would do it like this, if you materialize the modules themselves, if the modules would be having some properties, for example, color, or some other special properties, they would obtain them, like materials, colors, and stuff like that. It usually works like that, and it bakes it into blocks. And the difference between this, it's block instance, and this is just an open surface. And so this also it has a name. these blocks has names and this doesn't. Like you can backtrack all the modules and how they are called, and sometimes you can like look how to create these, like what's the problem in here, for example, like okay, we don't like that these modules connect to each other even if it itself, so we could do it, yeah. So this was the easy example, basic example, and I overdid it, but I think I explained everything we had, and it's been quite long. But I hope we have still plenty of time, and I also created the other example, and I think you will play with it later yourself. It's already pre-made. And I think I will let Kristýna talk because I was talking for almost an hour.
Yeah, you were talking like 3 times longer than we expected, but I think it's like totally okay because you get into the points and you were very in the details. So I think we are like totally fine, and I'm suggesting to make like 5 minutes break.
Yeah,
to
it was
know to get inside all the information, and then I will continue with a little bit similar example, the neons, the lamp, but yeah, I will do it a little bit different. So I think
I think you don't need to explain like what you're doing right now, because I literally explained step by step everything. So now everyone knows that what is my module. So
yeah, because in the beginning I had a plan that we will like draw everything and we will go from scratch, but I think I changed my mind to that plan that I just will show you what I made, because if we will like make everything and draw everything, it will be like 2 times longer. So please download the files, and I would like to please Michael if he can copy the files into the Dropbox files, if it's okay, or you can download it from my link. I send it to you. It will be like a little bit more efficient. Like, you know, the amount of information will be the same, just a little bit more efficient, if it's okay. Thank you. So I'm suggesting like 5 minutes. Like at 50 we can continue. It's okay. It has to, because I need a little break. Okay.
yeah, let's get a
See
break.
you. Okay, maybe start. I will. And okay, we are ready. I wanted to show you yes, in the conversation, there was a topic about the grid. And yeah, the current plugin is prepared only for ordinary grid. It can be, like Michaela, I think, was talking about it, that the slots, it's not necessary to have the same sizes, but still they need to be orthogonal. But it doesn't mean that in the end you cannot work with the data, with the output. The output doesn't have to be like the total result. And also here in this game example, we are not able to solve these connections of different topology than the rectangular, but still you can play with the grid. You can like squeeze it or whatever. And this picture once I made like mostly like a joke, but the principle is like this, that the relationships and the rules are like orthogonal, is the same, like one unit in this picture 2D has 4 neighbors, but you can play with it afterwards. So the output data, it's not necessary to be like it's not necessary to have the final result only from Monoceros. I think it's quite interesting to combine Monoceros with other plugins and features. So it was just about this topic. And now I would like to show you the neons. It's this example. It's my lamp I showed you before. The principle is quite same as Michaela showed you before. She was quite precise, so I changed a little bit the plan. I won't draw it from scratch, but I will show you what I made and why, and there'll be some more little features, and you will see different approach. So you should have these files in the folder. So you can take a look and just watch me, and I will explain you. Okay, I'm sharing the window, not the screen. Would like to share this. Yes, now you can see. Now we will see the different. Okay, I will share the screen. It's yes, now you can see the neon one. The difference is that I work with two structures. One is light, and the second one is a structure, like the holding part. And the point is that the light parts can connect only to the light, and the structure can connect only to the light. So you will have like 2 pathways. And also I have modules where those paths are connected. So in the beginning, I have these 6 modules. They need to have unique names. This is my quite Where is the file? Well, it's in the example folder. Like somebody help him, please. And okay, you can just watch, and we will solve it later. But yeah. So be careful. The modules needs to have a unique names. It's my very often mistake that you know, there's still the end is still a red, and I'm like crazy. I don't know why, and then I realize that I have same names. So I think this is a common mistake. We were talking about how create the inputs for modules and for Monoceros. There is, of course, a lot of ways how you can define it. So now I'm using like really stupid way how to reference geometries. I just simply draw it and reference it here into the box, and I draw the box and reference it here. But you know, you don't have to draw anything in a Rhino and just write everything is a Grasshopper. But I think it's like clear. But for a good understanding and visibility, I just made it like this. So we have light modules. Here we have structure modules, and this is the combinations. These geometries, it's just like a representation. I need two types of geometries to generate two types of rules. So the rules for suggesting connectors, rules like Michaela already told you, but I will show you on this example that if I put these two connectors together and I will like join, then these curves will join in Rhino. So it means these two geometries will connect like connectors between those two. So you can before you will try to create the rules by suggesting the connectors, you can check it in Rhino like this if it works. And be careful, you have to be very precise. You have to be very precise in drawing your geometry. It like really needs to end precisely on the edge, on the boundary. Because if it will be like only a little bit from here, it won't make the rule, the connector and then the rule. So yeah, be precise. Because it's also a very common mistake. And yeah, and it's the same for the second one. I created polysurface because then it can't be connected, you know, together. It just works with those types of modules. So now we have 6 types of modules, and of course I want the rotations. And you can say in which axis you want the rotations. And now because we are in a 3D and it's rotatable in every direction, so I have true in all of those axes. And this is one of the good features of the Monoceros Pro, because this module rotation isn't in a Monoceros basic, and I think this is quite helpful that you don't have to do it by yourself. And yeah, so we have plenty of modules, and now we want to create connectors. There is again more ways how to suggest the connector. I used suggest the connector from geometry, but also you can use suggest connectors from voxels, and there you can say the resolution. So it should help you if you are not so precise or you have more complex geometry. And you can set up the depth of how much it should like scan the geometry. So it should work if you are not so precise, but it makes the same thing. It will create me two types of connectors. We can make a preview. I don't know. I'm like very often checking it visually. If it works, you can check the data, but also you can check check it visually. And this is the rotated connectors. And okay, it doesn't work for this, but yeah. Okay, now it's not so visible, but still here I have yeah, free rotations, and the connectors are created on the edges, on the ends of the stick. And sometimes I'm just check it if like randomly if it makes sense or not, because sometimes like you made a mistake in creating the geometry, and then you realize that some of them are missing. So this about this. We will create the rules for those connectors. And now, as I mentioned before with the picture, that we have to like set up rule for every connector. So now what we're gonna do with the rest of with the other sides? Well, one way is to draw it by hand, but I don't know like you, but I don't like you know, saying things step by step precisely. So we can like analyze it, which connectors are not used. So for this, we have this part where we get all of the connectors. Then we analyze them, which of them are used, and sort the used and the unused. And for the unused connectors, we will create the own rules. We are often name it like indifferent rules, because this name comes from the previous version of Monoceros, where the unused sides are like indifferent sides, and they can connect like to whatever they want, and to each other and to the boundary. This logic is a little bit changed. In the previous version, there is a component for it. Now you have to like create it, but I think it's like more in the logic. So this is the rule for like the indifferent, the sides without connector. And we are almost in the end. And now we would like to place it somewhere. I can use like a grid. Now I have a homogeneous grid because the cubes are regular, or I can slice some kind of geometry. It can be like whatever you wish. You can draw your own. Yes, I changed the grid box diagonal because my lamp is in a module like 30 to 30 centimeters. So I changed the diagonal. And yeah, and I also created the empty module for outer layer. Okay, there are some questions. I will finish this workflow and I will answer later. Just to finish, maybe it will be clear afterwards. And yeah, so this is for outer layer module. I will make it bigger. And again, for the empty module, I have to create the rule. I created the rule that every connector of this can connect to the other connector. Then I put everything together, and we have warning. It's contradictory. Okay. It's interesting. Because it should work, it doesn't. I don't know if I maybe messed up a little bit with the structure. I don't know if your file it works, and it's interesting it doesn't. Contractually. Interesting. Okay. I just moved to the envelope and it. Okay, interesting. I just sometimes some random move will help. I just moved the envelope and yeah, it created the result. Okay, I will take any questions. Works fine without changing anything. Example, it works fine. Okay, but this is like a super stupid example, so it should work. Maybe there are some hacks that you can increase the amount of attempts, because by default there's like 17, interesting number. I don't know why 17, but be careful about this number because it can destroy your computer. So you can increase the amount of attempts, or you can just change the seed, but usually it won't work. Or you can create like more simple envelope, or we can put it in the regular grid. You just change this to this, and the result will appear here in the regular box. Yeah, I don't know. For me, it works, and also the rendered example is in a quite like a more complex envelope. I mean this one. It was like, you know, because the structure was rigid, so we made a more complex envelope. So, but it's good to start from easier things, like try if it works in a like a very simple envelope, and then try to make it more complex. But as I said, this is like a very simple example. And yeah, just about this materialized slot, sometimes it's fine when you shut it down, and before it depends how powerful is your computer, but sometimes if you make like a more complex geometry in the slots, it can take like quite long to materialize it, you know, because it has to put all the geometries into the slots. And if you make like a quite big envelope, it can take a long time. So sometimes it's better like wait if it finds a solution, take a look in a report if the solution is found, and then turn this on. So it was the first part. The second part, this is like, there's like two. We want to make some legs for our lamp. So we would like to add one component, one module. It will be called end, and like you can make whatever you want. This is not like some super nice geometry, but it's just a representation. You know, it's for creating the rules and like to be the simplest as possible to see the mistakes and to make it much more simple. But these simple geometries you can then replace with more complex and more designed geometry. I will show it to you later, that you can work with one geometry for rules and the second geometry like to make it more nicer and not so basic. Here I took the geometry from the structure and put some like a stand. And the only difference from the previous example is that I constructed a special rule. It's a rule for it's a connector and rule for this side. And because I want this stand to be only on the on the bottom. I don't want it like in the middle of structure or somewhere else. I don't want to make it rotated. So it's like totally separated. And I created a connector only from this by point. So now it makes sense to create or set up the connector by hand, by point. So this is the connector thing. And then I have to create the rule for it. The rule is that I want this side of this module to be connected only to the outer boundary. So I used the why is not before cross? I used construct rules from connectors and modules. So I took the connector I created, and to the target module, I put all of the from, okay, I turn it on. Yeah, I connected to the outer module. So it was the only difference from the previous one. And then of course I have to put everything together. And we will see the result. Okay, there are not a lot of stands, but we have like at least 2 of them, and they are in a bottom part. So maybe if we change the seat, it will change also this, but you know, you can play it with this. And the third part is that it's not necessary to have modules only like in one box. You can draw them freely, like in more boxes. It's up to you, and they don't have to be like this, rigid. Also in the example, there is like these tubes, and I think it's good for the design that it doesn't look so rigid, because the results from Monoceros have tendency to look very, very rigid. And so it's like our internal game, how to get rid of the grid. So yeah, I draw this curve. It can be, for example, like this, but again, because this is geometry for making the rules, I put the ends of this light representation geometry precisely in the middle of this side, so it can create the rule between this side and this side. So again, if I move this module here and make join, it will join. So then I will have a continuous light. And you can see it in the third example. And the logic, and okay, this is also difference between the previous Monoceros, that here there are no like mega modules. Everything is just single modules, but they are like with special rules between them. So the logic is that these are like 4 modules, but with unique rules between those touching sides. And I created this by component sample geometry. When I set up name, I put a geometry inside, put all those boxes, and this component makes think that it cuts the inside geometry into pieces by the cubes. But then I will create the connectors, and it will create me also connectors like inside of the geometry. And there is another special component. It's called rule exclusivity. And what does it mean? It's especially for this case that if I, put also these rules like together with others, that there is a possibility that if I draw it intentionally, like totally in the same position as this, it will connect me, for example, this to this. But I want only these two connections. So I made those inside rules exclusive. So they will work only for this part. And here I put all another rules. So this is the only difference. And yeah, I know that doesn't work. Funny. Okay, I make sure if it's turn on everything. Still red. Okay, interesting. So we will start from this more simple. Ah, okay, it works. But yeah, it's okay, we can see that there are some of those spaghettis. Okay, one. I want more. Okay, you see some seeds won't count, and it's because of as I showed you in the tile example, that sometimes it put randomly the first module into the place where there is no solution. So, but it's a advantage that it will count the solution like whole or nothing. This is also the reason why it's called wave function collab. That's not a growing algorithm. It looks like, because the propagation of the change is like growing, but in overall it should make like in one time. So there is only two options: the solution is found or not. So it found a solution. We are happy. And well, it was a little bit speed up of this example, but I hope it's like everything is clear. Okay, this is part of parallel solution. Like everything is clear, or you want to something like say it again, because I think like everything was said by Michaela before, and this example is quite similar to others. So maybe we can move on, because we still have a lot of interesting examples. Okay. And you have the files, and like, for example, for me, it works if I make like reverse engineering then by myself and play with it a little bit. So I think it's not necessary to maybe continue. Michaela, may you continue with other examples?
Yeah, sure. Yeah, I'll also try to speed up, but my examples are actually like a copy paste of each other. I mean, just like the format I used, it's the same. The solver, all the lines are drawn the same way. So it should be slightly more quicker as the previous one.
But maybe you don't have to speed up, because you have a different different workflow. And okay, the counterparts are a little bit like pipes, but the surface is quite a little bit different logic.
Oh, yeah, it is.
So, like, take your
The
time.
logic itself, I'm just saying I don't need to do like a interface guide again. So that's already off the table. I hope everyone can hear me again because last time I moved around and some people had some problems. So I hope I think Kristýna can hear me perfectly.
Great.
It looks like. Okay, so I will take let's take back to my, Kristýna, can you also like check, there was some Q&As and I tried to answer them, but we still have some unknown assembly, a DLL problem, which is still, I think it still doesn't work. I don't know, Adriana, you were writing about it multiple times, and I just don't want to make you unhappy that it's not working, and I'm not sure how to help you right now because I'm not sure what the problem is. Yeah. Anyways, like if you could continue chatting with her because it's making me sad as well. Oh yeah, it's absolutely, if it's locked, then it's that. If there was some problem with the DLL itself, like it's definitely that. Yeah, Pedro asked the question.
Yes, you have to, like, totally.
Oh yeah, yes, you have to. It's at least you're gonna learn. You know how many times we were redoing with every like release of the larger number of the Monoceros Pro.
Yeah.
We are working for 2 years on the same examples, just because we just need to redo it all again, because we like every component changes and it's not, and we have some back compatibility, of course. However, it's still, yeah, good luck. But it should be easier, and the workflow should be like different and maybe cleaner. I got also another question I'm gonna try to answer live, Chris, but it's for you. When you dispatch the list, it's the same way of as selecting unused connectors of the analyze connector node. Do you understand the question, Kristýna? Because I'm not sure what was it addressed, because I was snacking.
Yes, because I used the. I think it should be the same, but also Jan and also you did this the same. That the question if you need the dispatch, because the analyze connectors will give you.
Analyze connector. Oh, we have a new release, Kristýna, and the last section now also provides the only unused.
Yeah.
So it's the same. It's so new that Kristýna just doesn't use it yet. But it's there, and you don't need.
This is the thing about the releases, because it's like new release, but yeah,
it's more than COVID. Like we are rapidly improving this, and Jan added it very recently. Like yeah, you don't need to have like so many spaghetti monsters around. So yeah, we don't need to dispatch. I think it's done. It's the same thing.
Thank you.
Yeah. Okay, let's move on to my other example. And I'm just gonna show it. I will really quickly come back to this, because this is called in the examples heteropiping, and I'm showing essential part because I'm showing that not all the slots needs to be the same size, and it's the same thing as this, literally the same thing, just on a different stuff. I'm just gonna open it, and you can play with it at home, because you have all of these files already from me. And I have this is some sneak peek. I will close this, and I don't want it No. Okay. And we should go to the heteroplumbing because we have a homogrid and heterogrid. So I call it heteroplumbing, even though it's a Pride month. This is a heteroplumbing. This is what could be. It's the same two components as before. I just went a little bit crazy just so you can see the different sizes of different, and in this case, sometimes it doesn't. Yeah, I will explain it just super quick. Kristýna actually measure my time because I am unstoppable and I talk until the morning. And I mean, for some of it's a morning, but we have like 8 p.m. and I would be just talking. Eventually, I will be able to. Eventually, I will be able to put it here, like this. Wow, I think it works. So basically, nothing changed. I mean, something changed. I just complicated my life so many times here, but it's just, I'm gonna quickly again buy for close because so you can see everything. And also I'm so much not used to the icons. I don't use them. So it's funny. So I am just creating, so the main difference is I created a grid successfully this time with this Monoceros, where is Monoceros Pro, with not the homogeneous grid as we had before. It looks almost the same, but I created it with the heterogeneous grid. And you know, this funny component I never used before in my life. After we started to create Monoceros, it's a gene pool. I should be, because I don't know for what you need it, but gene pool is apparently useful for Monoceros, and it's here. And it's a heterogeneous grid. What it basically makes, I don't want to break my stuff, so I will just put it sideways. I just need again some point. I'm just going to create it like this. So we have a point and we have XYZ, and we can put multiple parameters in the same XYZ. So it basically means that you can have like how many like whatever. I will just use gene pool. So we have like by default nine slots, so we let's go ahead and put it here. It's somewhere there. I'll put all of them because I cannot see anything. Okay, this was the problem. Okay, so I will just put this one because it's too complicated. I will just put one. Okay. Imagine that there is also the third angle, but like, so we can actually just change, switch up every single row and you know, column and everything, like an Excel table. And you can, if you are brave enough, you can create all these different size modules. I wasn't. I created only two because it's complicated as it is. I just created actually three, because there are some three sizes. There are some in between. So I created more like slots which can contain modules which are sized 150, 150. That's oh yeah, no, 100 and yeah, 150. Then it's like the full one, which is like which is like 300 by 300 by 300, and then something in between, because clearly there needs to be some interpolation between these two. So there is 150.300. So so we have these 3 dimensions of modules. So how to create these? This is a box. I don't know why I used it. So I created the same modules. I just named it. I just put it in separate boxes just because I am doing so many operations with it, and I'm also rotating them and everything. That in the end, for every from these 2 lines, I have 21 and 84 modules. I just created out of these 2. So so firstly, I just rotated them, and default was my 300. This is my favorite in these examples. So I rotated all of them, and if I would stop here and if I would put it into normal grid or homogeneous grid, it would work as previous example. But I wanted to complicate my life, and I also scaled it. So so this is all the possible. So you can do many things with Monoceros modules. You can scale them, you can rotate them, and they will not change the properties. They will keep the names and everything. So I created modules which are half of the size of the original ones. So this is the original ones, this is half of the size, and then which are scaled in one direction, in the other, and so on and so on. And then I proceed as usual, and you can play around with it. I just created the same way the modules. However, the only mistake, the only difference is, as I said previously in here, solver, it actually doesn't understand the size of the modules themselves. It just solves the rules according to like the very next neighbor. So it actually doesn't have so much the information comes through, but the information comes through from slots, but it doesn't come from modules themselves. The thing that cares about the actual size of the modules, and it's made like that, so especially for this example, that you can have multiple modules. If you would go through all of these modules, they would be named the same. You can have multiple modules with the same rule. The only thing different is their size or their scale. It's again slightly against like idea of what is a discrete module. Maybe someone who knows something about Jules Retzin correct me, but I think like this is very useful in the sense of our plugin, because you can have same rules. You don't need to create it like multiple times for every single module, or maybe create like all the possible like different other modules for every size. You can just solve it with one size, and then the materializer, it will choose which fits actually into the box, into the slots which we created, and therefore we have, if you would choose not to have all these rotations, it would say it doesn't fit, probably, maybe. Yeah, it's said like it doesn't fit, like because we have only 300 by 300 now, and if I just do this and it says it fits. something. Some didn't fit, but it's fine because it found some other modules that fit. So the essential part is that they have the same name, and they have the same properties, so they have the same rules they inherited from the original size. And then you can just copy them, and then you can just scale them. You can put like different kinds of geometries, and the materializer itself can choose like which one it will pick. Basically, shortly said. I have also other examples, so I will not move around it. And in this example, I just decided that I'm gonna demonstrate it on curves and actually like make it visible that these were actually originally from this one. So I made like the curves like these two obviously are not the same size. It would be funny if they were, but if I would rotate it, maybe 90 degrees. Yeah, there's no way they would be the same size. Maybe they are. Oh no, they don't. They are not. So you can look around it and you can tinker with it. I just don't want to. Yeah, they are not different size, and they are like slightly otherwise skewed. And it's just because I created the pipes only in the end. So you can do multiple stuff. Also like not only with creating modules, but like also with post-production and also with the scaling and all the stuff. You can create more interesting things than just like rigid repeating modules, like very limited repeating an amount of modules. And this like after that. That was this short example, and I'm gonna rather go to the other one, and which was the counterparts, and that is this one, and that it's finally something else than the previous one, because it was a lot of plumbing today. And now another abstract example is the one which actually we used, or like very similar. We also had multiple other parts which were also counterparts within the modules themselves. It was just simulating the way how things actually are when we have some modules. We cannot connect them like the geometry in drawing, but we need to somehow think about the connection itself and how it's gonna stand up. So so actually this is also possible, but it's not the same way as for example WASP or something which is aggregating something on some different mechanism. We need to lie to our solver basically. And I will show you what I mean by this. So we have counterparts, which is this one. So in the logic of Monoceros, I still wanted to operate on that I'm gonna suggest the connectors according to some geometries, which are, by the way, it's the pipes. It's basically the pipes. I just made them like rectangular and flat, but it's the same as the previous example, the same logic and the same amount of connectors and everything. I just made them flat and rectangular, and so now these can connect only to the neighbors who are like the same orientation and everything. I'm also showing that you can filter out your helper, and you can differentiate your helper geometry and the geometry you actually want to have it there. And that's I filter it around like just this is a mesh and this is an open surface. So I just filter meshes with open surfaces, and then it's the rules are created by these, and these are completely ignored in that they are just transferred along with with the modules that are actually useful in generating some kind of rules. So I'm gonna open the Grasshopper, and I will talk about why am I lying to this solver. Can be parts. Okay, so it's I literally did the example like on purpose. I just copied the pipes and I just duplicated it. So the workflow, if you once start, like if you once do one definition, you can reuse it like many times and use it for completely different things, just by adding some other aspects. So the same as the previous example, I have my modules which I have named module A. I need to switch it up. Which means that I am suggesting the rules. I'm also rotating them the same way as I did with the previous ones. However, I also suggest the rules the same way, but one thing came here, which wasn't there before, and this component is again bifocals. This component is called the disallow rule. So disallow rule is actually a little helper by which you can literally disallow rules. So so I like to do it. Everybody does it a different way. I think Kristýna is like firstly not creating so many rules. I create all of them and I don't care. And then in the end, I collect everything and I then say like, okay, then but this is actually a lot of rules. Yeah, and in the end, I have like some amount of rules, and I don't care about most of them because most of them are indifferent. But I say like what the solver cannot do. I allow everything, and then I say, okay, you cannot do this. And in this case, I created two sets of if I didn't think of the geometry, which is my helper geometry, which is actually generating the rules. These would be, I'll just lock it and hide it. These will be completely identical. They are the same set of like final geometries. So it's completely the same. The only thing different, that's the orientation of the geometries which are actually joining inside of our construct rule, they are opposite. And for the obvious reason, you need to put one into another. So this is the only way how to say actually to I was thinking about this for last year when we were doing this the example. You can see Miro, and also in the digital modularity. I was thinking about it like how can I create like something which actually doesn't join. It actually works on the other logic and then just joining. So I actually am joining them, but not with the same rotation as it would be expected of it. So I just rotated the orientation, and now I am I also rotated and created all the rotations of these parts itself, and I suggest rules between them. And when I say disallow rules, I hope this will work. Yeah. When I say disallow rules, I did one thing. Firstly, I mean these two. This is module A and module B. In one, it's this one, but it's actually this one, and in the other one, it's this one. I put them into separate groups just because I am doing one operation before I do before I do everything else, I suggest the rules within itself, but and also I'm suggesting the rules like with all of them. So if you can see, like I'm collecting module A and module B, and so module A, module B, and also empty, and also my module which I call out, which I already have. This is the same from the previous one. I am suggesting the connectors, like everything can connect with everything, but I'm saying at the same time, however, these two cannot connect because it's, first of all, I'm putting there some geometry which is like overhanging from the actual module itself, which is completely valid and completely possible. And in my case, of this little contraption I created, it works just because I put it into a bigger box than necessary, and then I just scaled it back. But it's completely valid and completely possible if you do it manually without my contraption. Just to put any type of geometry anywhere, it doesn't need to be inside of the module, like absolutely to be here, but it would be placed in the relationship towards the center. So that you need to keep in mind. So I put like the mesh inside, like, which is like overhanging, but this is not possible like in the real world. It's actually very necessary in between these two. So I need to disallow that this group cannot connect within each other. So I suggested rules only for the modules named like with the start A, and I suggested the rules, and I created this set of rules, and I did the same for the other group. So I suggested only for this group itself, and then I collected these two, and I just put them. So these two, these cannot be like friends with itself, and this group cannot be friends with itself. It can only connect with the other friends from the other parts. So disallowing rules works. You cannot disallow what you didn't allow previously. So you can only erase the rules you created before. Otherwise, it doesn't work. And let me rephrase it maybe. And then I'm looking if there is. Oh yeah, thank irregular cells. Okay, I was looking if there was some question. If you would put some rule you didn't create it, how to say it? It just deletes. It doesn't add something which wasn't there before. So if you would create it, if I would create right now some completely irrelevant rule, it wouldn't change the amount of final numbers. So if I would be able to do maths, which I don't, it probably adds up like in the end, and also it duplicates, but it dissolves this amount of rules, so it just deleted some amount of rules from here, and now it works. If I wouldn't disallow this, it would create quite a mess. And also component human, I think it's human. I'm using, oh, it's elephant, similar thing. I just filter, that's maybe it already popped up in your stuff that you need also elephant, but you don't need elephant to use Monoceros, but I like to use elephant to filter meshes and surfaces and stuff like that, so I don't have to do it manually. So it would actually, you know what would happen? It would actually create something which is not possible. So that's another example, and I think that's quite understandable from itself, self-explanatory, because I'm doing basically the same workflow as previous one. I'm just creating two groups instead of one. and I added one more thing, which is disallowing rules. So that's basically this example. And we are all like, we just want to create all the like show all the possibilities of the Monoceros itself. So let's just check what's next. Oh, and we should be doing also landscapes. So yeah, all the simple rules will be within simple examples will be in the same sitting. So if you have any questions, don't for sure ask. But I don't think I see any questions. So you can play.
There was, but I will answer it after your part.
Okay.
So
Okay.
continue.
So I'm gonna do the last example, like the basic example I prepared from before, if this one is clear. And that's slightly different because I am sampling geometry I created before, and it's called landscapes. And finally, it's something create some continuous stuff, and it's just I before created this very, it needed to fit into my grid. You can try it yourself. Like if you can sample any kind of geometry, but it would sample it into many modules. So I specifically created like some like logical amount of modules, which I will show. And we have two options how to then apply it, either like as a continuous something or closed islands. So it's called landscapes, and it's also in the files. And yeah, this is my volcano I created, and I purposefully made it like larger than the sampler itself needs. And I'm always spoiling what I'm gonna finish later. Anyways, and this time I will not forget the bifocals. Oh, for what am I using bifocals if I don't have the file open? I think it's this one. Oh no, my mouse is not working as I want to. Yeah. So basically, my trusty vector is set on 300 again, and I am creating the slots as in the previous two. I just sliced some balls. So that's what I did. However, I have again the same copy paste out and empty because it's useful to have it. But this time I'm creating models completely differently, and I'm creating it by giving it a sample. So this is my sample. I am creating a homogeneous grid, which is this, and I created just the two rows because I made it like that. So it's somehow also logical in the logic of the modules itself, because Monoceros cannot suggest rules which are on the edge of the, like on the bottom. I don't know if Kristýna mentioned it before, but it would create like some problems if you would put it directly on the edge. It wouldn't know that it needs to only touch the grid itself. But like this is fine, but it wouldn't be fine if the whole thing, let's see what would happen. I would put it here as normal person would do. Now my computer froze, but that's not part of the show. Yeah, and it would probably suggest some kind of rules, but I'm not sure if it would suggest say the right rules as I want, because I know from the past that's yeah, it creates the module. It's fine, and I will look. Also it samples a different kind of modules than I expect. I will first try to do it the way it's supposed to be. Yeah, it's sampling completely wrongly because I did it so it's bigger than I need, because actually it's this component is called bifocals. It's not called bifocals, but I should be having bifocals. It's called sample geometry, and you can find it in the grid, and you can just put some geometry into a grid which is surrounding it. I don't know, it's a hard word. And then I didn't create name because it has some basic like module and like a little line after. So I set it as default. It's gonna be called module 0 to some amount of hundreds, and it basically checks every single, it slices every single geometry within this. Yes, that's exactly what I'm. Yes, Oliver. I can just. That's yeah. That's Monoceros Pro, everyone. You can just you don't have to draw anything. You just it's not as simple as like it works on a limited, like this is not God tier. If it doesn't understand, if I put it on the edge, it's gonna freak out. So like there are some limitations, but you can just draw like some, yeah, this wouldn't work, and like this would be really unhappy, and like I prepared for you. It looks like you need to try it yourself. So yeah, it works on the edge. You need to keep in mind like how the modules are connecting with each other, because that's how I drew it basically. I knew that it somehow regularly meets on some normal amount of points, like this meets in the middle. I basically drew it like that to make it work like this smoothly. If I would put like an actual landscape, it would have a hard time. I don't recommend it. Even with I don't have the worst computer in the world, but I wouldn't dare. But yeah, if you make it nice and regular, the geometry, maybe export it from Minecraft, or like maybe like it would work if you have in mind that you are going to sample it with something which needs some repeating amount of yeah. Yeah, so I'm just sampling these, and it actually doesn't need the whole thing to create another thing. It needs only, it deduplicates all the modules. So these were the same. So it has module 0, and then we have some other type of module which is like 354 and 40, and it deduplicates so many repeating patterns it sees. So it sampled only what it needs, and now we have sample modules, and we have only 40. which is like a nice number. I manually create like 200 modules sometimes when I need it. So we have only 40 modules, and I don't know why I didn't suggest rules here, or maybe I just disconnected it. Anyways, let's see. Oh, because I created them there. I don't know why I did it here. And I'm sorry, delete this, scratch this from your stuff, because it works without it. It was just some leftover for my work. So that's some, and then I'm just the same way. I am creating modules. I'm creating rules from like, oh, every single module can be connected to every single other module. I think Kristýna is sampling in the, I will spoil, like she's keeping some modules together. Oh, I turned it off. I'm sorry. Oh, I deleted them, of course. That's why I'm putting it in the corner. And always, I don't like mess. So that's basically it. And I then did the same process as the previous one, and I put it inside here. And depending if I have a boundary layer, this looks like a mess if it's in a ball. If it would be like 1 or 2 layers, it would actually make sense. Let's try that instead, because this is literally just a mess. So I will slice this instead. I'm not sure if I'm able to. Maybe I didn't slice it correctly. Yeah, that's sometimes when you slice something. Why I don't have it here? Mistakes happen. No. Sometimes when I slice geometry, it's not completely perfect. It doesn't, something is not happy, and it's because it cannot fill the geometry volume, because it's smaller than actual module itself. So I actually would need to either scale it or just wrap it. And I'm just gonna wrap it because I don't like to do stuff in. And now I have 2 layers of my slots. So maybe this would look better. Let's see if it, yeah, it works. It creates some mountain, and of course I don't have any boundary layers because I said like out is not. So I don't have any regulations what happens on the boundary, and it can just connect freely to the outer space. So you would need to clean it a little bit, or you would need to think more about how to create it. So we have this continuous kind of terrain. But if I would put boundary layer, and since let's see what happens. And since I have all the rotations of this stuff just sampled from this, because I made sure that if I did this, I made also this. You would have to do it manually if you don't want this behavior, but basically what happens here, it can connect these little triangles to itself, which is cute, but like I don't know if this could be like some kind of this is not the behavior I actually wanted. I wanted to create like big islands inside of the stuff, but then I would have to do like bake the modules themselves manually, and then disallow these, or like track within these 40 like which modules these, like with what names they have, and then like say like, okay, these guys cannot connect to each other. but it would create also problems in here because it wouldn't create these kind of formations. So it's some things you cannot control like completely. And sometimes it just creates these little bits and pieces. But still, we in very short time we created like two kinds of behaviors, either the landscape or the islands, like floating islands, which you can do like with more advanced geometry later, and I think it's kind of cool. Like you can do many things in Monoceros, not inside of the actual Rhino and drawing modules themselves. So yeah, it's our favorite workflow, as Kristýna says, like we just draw a little bit, we just rotate it, we suggest connectors, we don't like from the previous previous workflow we had in Monoceros, like the regular one, like there were so many things we need to draw manually. Like we needed to draw rules, like we needed to draw lines, and there is still it's still kind of visible in here. Like when I draw diagrams, I still draw it like that when I show someone like from outside of Monoceros, like who works with Monoceros, I draw lines. So I say like this connects to this. We needed to explicitly draw them. So like we don't touch Rhino at all, but it's still possible to some extent, and it's very necessary sometimes in the Monoceros, the basic version. I think I see some questions. Do you have any suggestion on how to start solving from selected slot? Yeah. I don't know if I will be able to actually demonstrate it because I would need to also think about it. But I think I can add. Yeah. If I will construct slots, like lot of slots, it would be better to try it on the different. I will just say it, and you can try it. You can construct one slot here, and you can say it contains this module. It contains only not you will just pick the name of the module it contains, and it will contain that module. And around it, create all the other slots, which you would allow like all the other modules to be contained. Or you can list item, of course. That's the like you can just list one slot, like one box within all of these, and you can just separate it from all the other slots, and then you will say like, this slot contains construct slot, this slot contains this name. Is that? I think it's like that. If you know how to Grasshopper, it could be quite all right workflow, I think. But you can also tell me if you will try it, like if we will have Monoceros after. Yeah. I'm not sure what do you mean. Yeah, I think you can just list one and say this one. Perfect. So thanks for Q&A, and I think Kristýna wants to say something about the facades. My English is going away.
Facades.
Facades. Okay. I think I'm done with all these examples, and you can play with them later. So that's it. You will get homework. I hope you will create something more pretty than I did here. I will stop sharing screen. Yeah.
Well, there was one question, and I would like to reply. It was about if I'm putting the outer modules into also inside of the geometry. So I will explain this part more clear. I have this geometry, then I slice it into the boxes. I have a default method, the second, wrap, surface, and fill volume. So the boxes are also inside. And then I use this component add boundary layer. Now I'm using it for the boundary rules. And here I make construct slot only for the boundary layer. So it's here. And in allowed names, I put only the out. So it should be just only for the outer layer. And for the others, I allowed all of other names. So I don't know if it's more clear now, but this construct slot is for everything, and this construct slot is just for the outer layer. And but it reminds me that these out modules without like connectors and without geometry, we can use it also like an empty module to fill some gaps inside of the geometry. And I find the seed where the solution wasn't found. Like there is some gaps where the suitable module doesn't exist. But this is like a quick solution, and yeah, it also helps the structure not to be so dense, that I can allow also this like empty module to be also inside of the geometry. So I just plugged in these, and now the solution is found, and it's still pretty dense, but somewhere there should be gap. So, you know, it's easier, maybe here, it's easier to find a solution if you allowed like this universal type of module. So it's like cure for not finding solution, and it allows you more complex envelopes. And if you move it, you can see that it finds solution almost anytime. I don't know, it was helpful or not? Who asked me before? Silence means yes. So I hope it was helpful. Yeah, got it. Thanks. Great. But sometimes you need, you want different rules for out modules and empty modules, etc. So you can make like a separate one and make a unique name and unique rules. But with these simple rules, it's like you can make a universal module for it. Okay, and now we would like to move to more fun example. It's the facades. And the idea about this example came from our idea for Evolo competition. I think a lot of you knows. We didn't win, but we created great Monoceros, and I still think this project has some potential. The idea was that the internal structure of the skyscraper will be like boxes like this. It's also generated in Monoceros. It has some rules. There was also corridors, some elevators, blah, 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 etc. And then we made another Monoceros, which chopped the geometry and replaced the facades with more complex geometry. And the funny thing about these two pictures, that the first Monoceros, this white box basic stuff, was the same for both of those two examples, but I changed the production geometry. I just changed, yeah, from a Ricardo Bofill tribute to some weird Japan style. So this also like a way how to use Monoceros. You can put like more Monoceros next to each other, and yeah, and you can use different Monoceros for different things. And I think Michaela will talk about it later, but she was like iterating these Monoceros outputs. Well, and as we mentioned already before, this is our favorite component, sample geometry. So I will show you how it works in practice. Again, it's okay. You can find it in your examples. And I will start here. Okay, moment, this, yes. Order. Okay, this. So I started from like totally simple geometry. It's a representation of the facade, we can say. And I use this simple geometry for generating rules. I cut it into pieces by these boxes. So from one single geometry, I have like 9 modules. Put wireframe, it's more visible. You have 9 modules. Here it made like I put inside geometry and sampling boxes. It cuts, and then I want rotations. I want, because there will be some windows and you know, stuff like what is usually on facade. So I forbid rotation in a x axis and epsilon axis, because I don't want windows on the roof or underground. But if you would like to go more inception, you can allow it. But I was like only in a vertical position, so it's not you know, it doesn't matter. It looks like it's connected, but it's not. It's separated modules, but they are just looks like this. They are placed here next to each other, but they are separated. So now we already have like how many modules? We have 36 modules only from this. So this is about this like geometry for creating rules. And then I would like to place it with something more complex and something more funny. And this looks like crazy and hardcore, but the advantage is that I use the geometry pipeline. Okay, it's about this component that I can change it like instantly. It's a little bit of work that you have to, you know, type it like 1, 0, 2, etc. And then be careful where you draw what. But it gives you a big advantage. And when we take a look into the result, it's here. And then I will make a change inside Rhino. Okay. Make it visible like this. Whatever. Okay, for example, sorry, I will make it more visible. I'm thinking how they did this height and just wait a second. Just hide it. Oh, whatever. Like this. You can see it. So if I change, for example, this geometry here, it's instantly changed also here. Or if I would like to add something, so I know this one is 0, 1, etc. Like check this one is 0, and I would like to add to this module, like we can choose, like for example this. Yeah, and advantage is it can exceed the boundaries, you know, because for the geometry for rules, it's inside the box, but for the production geometry, it can be whenever you want. So, and I can move it, and it instantly changes. So this is the advantage of this little bit more hardcore setup. But as you see, you can then copy paste it, and it's super simple. And actually I used almost completely the same Grasshopper for the second type of facade. So I think it's a nice advantage of this pipeline workflow. And yeah, it's orange because geometry exceeds its gauge. It's we know it and we see it, so it's completely okay. Then, but we have to be careful that these two data trees has to be the same, because we are replacing the simple geometry with the more complex geometry, like after the everything is like solved, and the modules needs to have the same name and you know, same amount, like, and everything, because if it's not like that, it will make mess, you know. For example, this geometry will be replaced by this, and it will be like broke down. So you can compare these two lists if they are like completely the same. And also there is a different approaches how to create the module. On one way, it's like made automatically from the sample geometry. Here I make this entwine stuff to make the list same as here, as from the simple geometry. And this is some just like grasshoppering that I add numbers for the names. They are the same. And yeah, it's basically that. Then, because if I end up only with this logic, that you know, now I have like in a cut, in elevation, this. So with these types, I will be able only do like things like this. And actually not this, okay. So I have only these parts rotated. But sometimes I would like to be more complex, and would like to make things like this, but also like this, and go further, and like this. So this is the reason why I have these modules called universals. You can find them here, and you know, it's just like edges, because we can take a look at what it makes if I switch them off. I hope it. Yes, and now I have just only closed surfaces, and they are not continuous. So we have like a gap here. And yeah, because some of the geometries exceeds its boundaries, but they are not like, I don't know the name, convex and concave, you know. So we would like to make also more complex geometry than this. So these are the universals for the edge cases. They looks like this, and they are universal for other types of geometries. Is it only be able to apply for ortho? No, yes, this one, yes, like as I mentioned before, that everything works in a grid. And but there's a way that you can play with the geometry afterwards. Like also Michaela did it quite often. That for example, here there will be like some surface for populating trees in a I don't know which engine you using in Blender or Unreal Engine. So you can say these parts of surfaces I want to make them more like you can make some post process afterwards. So also these results, it's not necessary to have them like this. You can, I see, thank you. And yeah, this is the corner universals. We will switch them on. Switch them on, and also we need a lot of rotations. I have a mistake here. It's this. But no, it's not a mistake, because you can say, okay, we can like disallow these connections. But sometimes you want this connection, and then it will continue, with the facade. It will make like, I don't know how to say it in English, but when the two roofs connect, make well, not wally, but make a small gap. But now there is a new component, and it's really very recent and new component, and it's called slot pattern. I just explain it theoretically, that now it should work like that. You draw the situation you don't want to. So if you want to this situation happen, you draw it, put it inside this component, and if in the solution will appear this pattern, it will recompute it. But I don't have it applied into this example yet, because it's like really, really recent. Now you can see that the Monoceros is still like evolving, growing, and sometimes we are debugging it, because of course Jan is testing it, but me, and especially Michaela, she is like a super master to create super complex and use it like in a way that nobody will ever imagine it. So mainly
I just wanted to say that we have one example, but I don't know if I can play it. I'm gonna try to search for it. Jan sent it to me, and I need to find it. And in the absolutely in the end, we have like this section, and I will try to start that file, and we actually have an example for this, but it's super.
Yeah, we have. But I was like, forget it, because there is so much content that this is like, maybe, on the top.
Maybe when we will share in some story that it works. Now it's like, probably it's gonna work very, very soon. Like it just solves like parts of, like actively solves, just deletes parts of the unwanted behavior. It's super cool. I will share it in some story, or like Kristýna will, or someone will. And we will like follow it, and it's gonna come. It's gonna be like it's solving itself, and then it suddenly disappears like a chunk of things, and it's like it's cool. I just saw it like last week, and it's cool.
Yeah, I also saw it, but I think it's not the essential feature, and I didn't test it yet, so I was like, it is here, but I'm not sure.
It will happen. It will come.
But it can help you with it should help you with those patterns which you cannot like cannot disallow by the rules, because if you disallow it, it won't make, for example, okay, I don't have this situation here, but yeah, just I tried and it doesn't work. So this is for the edge cases, and also I need like the universal for bottom and upper part. So like basically this. I also made it universal like roof. So these are these two components. Yeah, and you can see that I have one old component. It was replaced by something else, but it's good that there is like a back compatibility, that it still works, and I will have to change the logic of things, and but just to show you that it's still alive. Well, and then with the same logic, I made the facade more and more complex. So I will hide this. And yeah, you can see that I created really simple, basic geometry for rules that I want those modules to be connected to each other, but this component, you know, like a door can connect to this part. And also I made the same size of the door, so upper part of this door can connect to the lower part of this door, for example, and this should be like the balcony, so also this part can be connected to this part. Yeah, I also made some like loggia, or I don't know in English, the inner part. And okay, I will show it, the production geometry, to compare it. And you can see that the production geometry can be much more complex than the original one. And you can really draw like really whatever you want. Of course, it has to make sense a little bit. But if yeah, and be careful of turning it on, because you know, if I have here like 36 modules, and if you see how many other modules I had here, so you have to be careful about your computer. I sometimes make this that I disallow the materialized loss, especially when I have a complex geometry, and then when we can turn it on. Okay, took time. Good. And it found a solution. Great. I can show you how it looks if it's with simple geometry, just because to see the difference. So it looks like a block of flats, or I don't know. And then here I replace it with the production geometry. It's visible here that all of the more complex geometry are connected to this in the same order, like they are the basic geometry is connected here. And see that from the basic geometry, it goes to all of those rules and slots and stuff. And this production geometry goes only here. Yeah, don't forget to connect it also with the empty module. And when I replace it, we should see the change. Yeah, and it's more complex. And yeah, if we turn on the envelopes, It depends on how your computer is strong, but I try to make like, okay, let's count it for like those envelopes, and it was like, half an hour. So maybe you can also make some script when when one counting is finished, then it will go to another. But I was like playing with it and finding the nicest seat. So it depends, but yeah, by this one simple by this one script, we created like 3 skyscrapers. And yeah, and we had to model just very less geometry. So it this approach is a little bit more close to the game design industry where it came from. Like we use it like a procedural design for generating almost like map. It's more like landscape than the architecture. And of course, there is a lot of things to improve because sometimes there is like some nonsenses, but I was like, it will be from far away, and I don't care that some stairs goes to nothing, to nowhere. But of course, you can play with rules a little bit and also the geometry, so it will make like sense and it will be more like livable. But I don't know, for like a sketch for me, it works. And well, how much time we have? I think, well, about the other stuff, not only the modules, is that here I have an envelope, which is this crazy box. Then I changed to the grid box diagonal different because we were like in meters, and we set up like half of the floor, so it's the model was half of the floor, so 1.5 meter. Yes, also I changed the base plane to fit the whole module. And I think if there is something special, because basically these things are quite simple all the time, that you need some module which you will put outside. I think I have still the same approach. It's also here that yeah, I've at a boundary layer, then I put the outside module. Yes, and there is that also I put the out module without geometry also inside, because if I don't, you know, it will be just really flat, and I need to put something also inside of the geometry, because I don't have like inside floors or something. It's just like fake facade, you know, there is no inside of it, so I don't have floor, so I have to put empty module inside. Yes, and I'm using I'm not sure why actually, but I think for this example, the suggest connectors from voxels worked better. So yes, and I compare to the results. Sometimes you can compare the results. Okay, we have 5,000 for 880 rules, and there we have a little bit more rules. So it looks like that this component missed some rules. You can analyze it later or like compare the results, but for this I use this one. Yeah, and there is a, don't look at it, it's the old one component, but it's cool that it works also with the new release. So it's a great, because some of the releases wasn't compatible, and this one was, so I leave it like this. But yeah, you can simple this part. I will replace it later, sorry. And yeah, also I have here one this allowed rule. Yeah, and it's about the edges, but it was just the only one. Well, I think that the other stuff was already said, and I'm not sure. Like maybe if you have any questions, it will be maybe more useful because I don't want to say some things again. So maybe if you have some like questions or also some feedback or impressions. It's great. Yeah, and I think it was actually the aim of this workshop that, you know, if you want to learn it and use it, you have to do it by yourself. But we really would like to show you different approaches and different scales and advantages. And yeah, but as you can see, I also sometimes do that. I just copy some part of the script to the new one because, you know, it's the same. You always need some rules for boundary. Of course, you can change them, but very often are the same. Okay, now the module logic is different. So I created the new one, but then I copied for the other one. So I think in the end it's not so hard because I confess when we were like going from the Monoceros basic to this like Monoceros Pro release, I was like super confused because something works like really different. Some was like I don't know how many of you already use the Monoceros basic, but I think in the end it's not an advantage for you because some things are like really different. Mainly the rules are different. Rules different. Okay, what's in our plan? I have a feel like that I am more quick than Michaela, but sorry for it. Michaela, do you want do you want to switch to housing? Maybe we can make a short break before the final headliner. And
Headliner, I'm like shy. Like, yeah.
no, I think like most of people just applied because of the housing, because everybody wants to generate, you know, architecture like this, and you will show them how to do it. I showed you like the trailer, the facade, how you can do it, and now something more real. Because
yeah, it's true. We are working on it. I just wanted to address a question from a chat that TV said, perfect. I just wanted to address the stuff about the documentation. I will tell the truth. It's just 4 people who are working on this whole project, and I was doing diploma the whole year. It's working since we started working on it 2 summers ago, and it was like we're gonna make a Grasshopper plugin, and it's gonna be called Monoceros in the end. Like we did that, and we after a year we finally released it, and then we wanted to like work on it more, and like developers are like showing interest in stuff like this because you can do so many things. You can use it as a beam, and you can use it as, it's still 4 people who are working on this stuff. We work in probably mostly for free, especially me. And like I do it like as a side project with my school and everything, and everyone is doing it like as a non-profit. So it's quite difficult to write documentation, like to even explain it like once, not write like documentation which makes sense. Jan made the documentation for the Monoceros basic. I have no idea when the pro like whole finalized stuff will be like eventually done, because Oh my God, we don't know. We don't know, but it's here and it's still improving, and we want your feedback also, and we want users. We need users because, and someone who can make actually something cool with the renders and everything, because I don't have time. I'm making housing for 2 years, and I still don't have any cool renders to like cool final product of it. Like, no.
Yeah, and I think it's also the reason why
fine.
we didn't want, because I think the idea is like super amazing that we have skins on some boring geometry, but as Michaela said, we are not very good in rendering or not good enough. So
We should take some desomorphine like cars
yeah.
or something. Yeah, but it's still like you either are in the behind of the grasshopper. Yeah, I should go tomorrow, like to that skins and stuff. Either I will tinker around the grasshopper until it's perfect, and that's also my diploma terribly failed, because either I will spend so much time on my grasshopper, and so it makes sense, and it's everything, all the rules are possible and it's valid, and that's what interested me, like that my grasshopper works. And then you need to make also a result, and I never made a result, like not a good one. So so it's funny, like yeah. Oh, you already combined Monoceros with Wasp. Right now, like you need to send this to us. You need to send this to us. We are like we want to see it. It's perfect. Sure. Like, yes, DM us. we really want to see all the crazy combinations of everything. Like I think someone did it with kangaroo, and also some with some other, I don't remember. And like, someone did something with caramba? You did something with caramba. Disappeared. You did something with caramba, right, Kristýna? Like,
kangaroo.
was it kangaroo? Okay. Oh, so many things to explore, and also we need to work as architects and stuff. So it's going slow, and it's going somewhere eventually.
Okay.
Yeah. Yeah. So documentation will be maybe in 2023. Question for housing.
While you were talking, I have almost done the city.
Oh, good job.
Okay.
Yeah.
We can switch to the housing.
Sorry, I don't know how to pronounce your name. But I tried multiple approaches, and I still haven't. I'm still not done. And I did break it down into some like same sized components, because it was the easiest way how to not lose my mind. Eventually, I will eventually try to like also make like small and bigger, and then I will need to do like something, yeah, or break it down into different chunks, and I will explain it very shortly. And I think I need to go for a smoke, and then I will be ready. Yeah. Basically, yes. So far, I did it only with the same with the homogeneous grid, not with the heterogeneous grid, because yeah, I cannot handle it. You will see. So like my grasshopper later, it's even bigger than Kristýna's. We are like in a process of like competition, who will make the biggest grasshopper. It's always me. But
No, that's not true, because I said that I like simple things and I make simple things. What happened? But I like to fabricate them, as I tried with the lamp and 3D printing and everything. And you do like very complex, insane grasshopper. So
It
I think
works.
it's like totally okay that it's different. Ah, okay.
Okay, I think this is answered. Can we get like a 4-minute break, and then because I will
Yeah.
also listening to yours, and then I will be housing mode. And I think break time. Perfect. See you in 4 minutes. muted. Welcome back. I already see a question from Hypercomputer. It was interesting in linking rules with the proximity of any third source. I'm just reading it. I'm not sure I understand. Hypercomputer, do you want to step up and explain yourself? Because I'm based on the proximity. I don't think I made anything similar, or either I don't understand the question or I didn't. If Hypercomputer is amongst us, you can also use your mic, because I think out of this,
Like, you want to change the rule like alive, that the rule is set up by point and you will move and then the result will change like live? Is that thing? Or sorry, we are like,
oh no, no rules. I'm not sure if
well, you can do it like alive. Like I made it, you know, I changed the geometry, I made it alive. So actually you can, of course you can, you know, you can set up some timer and disallowing rules, and it will like make different rules. But it's not live, it's just quick changing.
Yeah, because it would need to resolve itself. The logic of like the VFC.
But of course, it's possible. I wanted to make something, and actually, Jan made something also a wave function collapse for Unreal Engine. I think it's not finished yet, but the intention was to make it interactive, and it means that it will change slots real time. That, for example, I know you can draw the envelope by hand. So you can change slots. I showed you, you can change geometry, and of course you can change rules, but I recommend you that you have like 5 different setups of rules and then change them. And of course, if you put some, I don't know, timer and, but it's not alive, you know, it's just quick.
Yeah, I think the thing you mentioned that Jan was trying to do something on like for Unity on Unreal. Yeah, it was an idea, it was a sketch. It was supposed to be called Triceratops, and I think Jan was doing some GoFundMe or something, some startup or something like that. And I'm not sure if it's still alive and if it's still within plans. I hope it is.
I asked him now in our together Slack now, and he said that he doesn't have a time to finish it, but the function collapse algorithm works in Unreal Engine. But
yeah, we tested that it works, and
there is a question about Houdin implementation, and it already exists. I cannot use Houdini because it's like from another world and too complex, but I find some videos that it already exists, and we made a parallel chat with Mike that actually this algorithm works on multiple platforms, and more people use it also before us. So, but I think it's great because it means it makes sense. This algorithm, use it for not only for games, but use it also for design, etc. So if you type it, also I think Twitter is pretty alive about the wave function collapse. So you just can type it into the Google, and you will find like a lot of things. But I think that in a Grasshopper Rhino environment, we are in VR further than others in a user interface. Like, you know, it's not only about the wave function collapse box. It's all about other stuff, how to make inputs for it and how to work with it. So, but yeah.
Also how to make an object in like how to build it, for example, like there's it's still of course the Grasshopper stuff from us, it's still in the progress, but we try to make it as real as possible. And
but no, I think it's like completely usable. There are a lot of projects we didn't show you, but Jan he teaches at Barcelona, at Bartlett, and from Bartlett there was really good good projects, quite complex. So
yeah. We
it's
turned into discussion, yeah, but I'm not
yeah,
saying
show housing.
yeah. I'm not saying that stuff from Houdini is not buildable, but like which we also like try to calm ourselves down, not to make like anything too crazy, so we can still have the possibility to eventually apply it in like a real life architectural buildings, like stuff like that. So maybe that's yeah. Okay.
Yeah, show us something real.
That's still not very real, but let's try that. Yeah, sure. I should actually keep moving. Oh, this is not that. This is the sneak peek still. I was like behind the scenes. I was still tinkering with it because I wasn't sure if it's working in the actual now version. So we are here. We are. I think the ultra and advanced possibilities we already we're gonna over discuss it until tomorrow. So this is our last example. Like if only if Kristýna can show like bonus example that it works. But yeah, this is my super not cool render, but it was something. So the basic idea, and it was I just finished it for my school. So the basic idea was just to pick some sites, find some way how to create envelopes. I actually did this outside of Monoceros. It was just some sort of it doesn't even matter. Like it was some scalar fields, very so 90s. I did scalar fields, remapped it on like grid, very boring grid, and it gave me the heights of the maximum heights of the like floors, number of floors, basically. So I created some envelopes in to which I'm filling with something like this. And I think you already saw Corbusier's dominoes, and I tried to slice it actually, and I tried to create something like domino, but like kind of generative. It still was in the end quite boring. It wasn't making such a wild architectures, but it was doing something on itself, and that was quite all right with me. I will also show you, but I will just in Monoceros, but I will just try to go through it firstly. So I created these envelopes, which I filled with the first layer. This is like a multiverse, because I used like step by step, like multiple Monoceros setups to generate one result, and that's quite different than from our project Monoceros. I'm a pirate. Monoceros, it's just Monoceros. Yeah, of course. Yeah. If you saw this 2 years ago, or someone saw this 2 years ago, I did like 1 million iteration of housing in the meantime, and this was the first attempt, and I tried to solve everything at the same time. So I basically made some modules in the Monoceros basic version. There was still possible to to actually make one module which occupies multiple slots. And I just create some hallways which were like 1.5 meters, the same like 1.5, 1.5, and these were some multiplication of that dimensions. I just try to solve it all at the same time. And first of all, this was just hallways and rooms and some accessories and stairs. And it basically did many different stuff. I tried to like kind of make it so I can make sections through it, and nothing will like collide, and nothing will be not like it would actually be some real architecture. This one kind of was. I was looking into the stairs and the indoors, and it was quite wild. Like people have a balcony, and then they have some hallways and some weird Japanese situations. You can rotate it in the Sketchfab later. So this was like a first attempt to make some kind of functioning architecture. And the problem was, in my opinion, to try to generate everything with one setup. So like my third and fourth and all the other iterations were working with the premise that I should first generate something which holds some shape or holds some structural, it has some structural integrity and everything. So this for my school project, I just tried to sample like parts of Corbusier's dominoes, and eventually I had to slice it manually, and you're gonna see the mess I ended up with. I have so many modules, and it basically, creates these kind of structures on top of which I want to do another layer, and this another layer. So it's I had envelopes, and I just generated some kind of structures. I could like use multiple seats. All the seats were kind of similar. Like it was creating some sort of structures. And then I used these modules. Also, like they had like some hidden geometries inside. It was literally just boxes, and it was these boxes. They already, since they were coming together with these modules, they were kind of informed of what is gonna be inside, what is gonna be outside, because it can only connect in the same level, like in the same way that this is inside and this is outside. So I had like a framework, like I could differentiate what's gonna happen with the rooms, like where should be doors, where should be windows, and also where shouldn't be like windows, and where shouldn't be like this should be stairs, but like whatever. These were the hallways basically, and these were my rooms. So it was basically this, but I just did it a little bit differently. I just made slots for the modules and rooms, for the hallways and rooms. And hallways were already there since my domino was already like over dimensed hallways basically. And then I decided I'm gonna make a fusion with Kurokawa's capsules. So I made a little setup, and I created like this part is quite simple, and it's the previous example what you saw. We were doing with Kristýna also another project which had the same vibe as this, but we didn't generate Corbusier. We generated just like pipes, and around which there you could generate the same like inside, outside, just capsules around it. Which in the end, it doesn't have to be capsules. It could be it could also connect to other things, and it doesn't need to be like discrete boxes. But just for the simple like for the peace of my mind, it ended up like capsules, because this could be like okay, this is it, and it always had like, this is a kitchen, this is some base, so that there should be always some kind of doors and everything. And then another layer, we had a good diagram in somewhere, but I don't know where it is right now. But it always like started like from relationship to inside to outside. So it was like the capsules were like consisted of multiple parts. So that was the other layer, which is a completely another setup. And on top of that, every time I generated this, there was always some empty module. And from that empty module, and this is funny, but okay, I rendered every empty module as some box with a different scale. And so all the empty places around all the accommodation, and this was some kind of mistake, and I didn't change it. All the empty modules around the building, they can also inside, like everything was filled with little boxes. And that's what I will not show, because it's gonna explode. But I filled with I call it the mobilier, or I call it like some kind of pavilion or something like which could possibly in the end, like geometrically speaking, it didn't connect directly to the stuff. But you can generate like slots for the like step-by-step slots for like a next step, and you could possibly inform it about the previous stuff, and you can inform it with the next step. Like maybe you can that way generate kitchens inside of the boxes, or like sitting outside of the building, or some pavilions and stuff like that. So it was very abstract in the end, but it kind of worked. Like it was some kind of seating and like some like playground. It was all plastic. So let's get into that, because that was that's basically the whole idea, just to create housing step by step, like create a new workflow. I'm not sure if that actually happened in the end, but I tried. I need to close all of these files because I just created a new ones which were better. I hope everything will work now. So first step was the Corbusier, and I see the chat. Just okay. No one. Did you create a vertical void space by giving an empty component? Vertical void space. Do you mean in which part? In the last part. Of course there were some gaps, but empty component. Oh, it's show. Okay, I will probably show us. I'm also like out of breath. Jesus. Great. So first, I tried to sample Corbusier and it didn't work. So I needed to manually like copy. I did only this part, but there was so many. Okay, by points. There is 500. 500 modules, and it was because I will show it from the right side because that's most understandable. I hope. Yeah. Wait. I will just hide. These are just rotations, so I needed to manually make them just because the properties unfortunately were not are still not inherited when you rotate modules via the module rotation, because it only takes the geometry and it strips it from the materials and from the like it makes something more difficult than it could be. It just I needed also, like in the render view, I basically the inside and outside, they are separated by render color. That's basically the idea. I just then needed to separate them manually because I didn't have time to think about another grasshopper. So I just literally picked select objects after I baked it. So that was okay. Now it should look like this. Yeah. So basically, it's like it was quite hard. I was having quite a hard time to sample Corbusier so that the stairs would stay intact. Like the stairs could grow to the infinity or could stop at like one level. So I needed to make I need to divide it like sometimes on the half of the floor, as you can see here. Like I needed to separate modules which were like basically like slab onto slab, so the stairs would work in the between. And also I needed to half it on half, like somewhere in the middle here, because otherwise it doesn't aggregate correctly. So I created so many modules just so the stairs would be happy. So that's something, like stairs are like difficult to make in Monoceros, and not to like that's a quick fastest recipe how to create the largest amount of modules ever, basically. So I needed to it's like half of the floor basically, and the bottoms are slightly elevated and tops as well, so it didn't like interfere with anything other. And on top of that, the geometry I sampled wasn't enough, so I eventually turned it into mesh. And I will show everything because I will show all my secrets right now. The mesh it's a closed mesh, and it was like, yeah, super cool. It should suggest the right stuff on top of each other. Yeah, the stairs worked, but it was making some weird rotations because the columns are rectangular, and it didn't matter to Monoceros if it could connect like this, or if it could connect like on the 90 degrees and everything. So that's, I think I answered. I don't know. So it was like quite difficult. So I made actually, and I will now hide the meshes, show it on something which is possible. I needed to differentiate because since I didn't want to do the rules manually by some points or some some naming or some listing, because I never knew which module is called how, because the names were generated automatically. I just created like little helper geometries that would actually suggest my rules, and I just closed the mesh, and it was like this was just a production geometry, and this was actually the geometry which created the rules. So also this is the case where the half of the floor was basically needed to go on top of the other, so needed to go here. So I needed to create also geometries which it's basically here. I needed to create the geometries that also generated some rules on the Z in the not in the same way as it was upstairs, because it was a different kind of a connector. It was a slab on slab, and it wasn't like column on a column. So I had so much fun like thinking about how to suggest geometry by itself, and I did so much manual work on these just to make it work. Eventually, I think the second time I would do it, like I would find like a better solution than this, but here we go. So there are so many ways how to create some working structure in Monoceros. I always find the worst way possible, and this was also the case. So anyways, I finally did all the modules I needed, and I rotated them and I separated them into, so this is basically, oh, these are rules. I needed to also make some manual rules, which is, they were not like so little, but I copied them. So that it was, I will show in Grasshopper what I mean, because there were so many, so much stuff with just was allowed and wasn't supposed to be. For example, I don't know what was happening. Maybe I will disallow it and we will see. That's the best idea probably right now. So basically I did this finally after some time, and I put it into this monster, and I need to do this, and it's from my desktop, and my desktop cannot handle this. I'm not even sure you can, but you have no idea. Okay. I love the messages Grasshopper send me. I have no idea what to do. Well, me neither sometimes, but yeah. So I need to unlock it. I need to be sure, very well sure if it's turned off and if it's like disabled, because it takes time. But eventually we're gonna see what I mean. After my computer unfreezes. Oh, that's not so bad. So I will turn everything off because this is bothering me. And I have something, I just need to, what's this? I probably have these, oh yeah. Okay, so basically my contraption, it doesn't change because I just copy paste it. I'm lazy to do that, like I don't want to do that so many times. And again, like this poor boy, it's the module is 3.6 times, like on the Z it's 1.8. So that's what the question about, like 5 times 5 times 5. For me, the right module was 3.6 meters times like half of the, yeah, half of the module in this direction. And it was creating some like all right dimensions of architecture. So that was my slot diagonal. And look at this, it's terrible. So anyways, so what's this? Oh yeah. So I've basically separated, I will turn this on basically. I basically separated, so I needed to somehow control like what goes with what. So only this could go with this, but this couldn't go with this because this would create some kind of other problem. It's this is in order of how like it's even elevated. Like this is also in order how it should connect to each other. But also there are some stoppers like some roofs, and it's in this level that this could stop you at the first level. Also, then on the second level, is actually this set of roofs. This is basically just the roofs itself, and they don't connect somewhere else in the top. So yeah, basically this is like my generic module. So it can. This is a roof. This is the edge of the cornice. So it's basically this part. I don't know why the colors are not here the same, but it's basically this edge, and yeah, it's self-explanatory even from this picture how I sliced all these stuff. Yeah, this file is still not there because I was testing if it works because it was from previous thing. I will put it there. Just be careful. Like don't play this. Like lock the stuff, and I will put it after. Or I can put it right now, but I can put it only on our drive, which you can find here, and then someone please put it on the correct one. So I think I was answering live. Oh, and I think I answered the Cyrus question, I hope, because it looks like there was like, oh, I see. I can put it on this drive right now, and you can like go with me if you want. I will put the whole of this stuff. You're gonna explode, but my computer is like breathing very heavily, so it's gonna eventually come there. I was just checking if it's still working because it's super heavy. So anyways, I sliced the corbusier, and then I did like a lot of intervals. So for example, this one was specifically, I need to see it. So it was this. Okay, so this was, these were about stairs. I had a lot of problems with stairs. So these stairs cannot connect with the stairs of the like a mirrored rotation of the same size. Like there were multiple problems. So these were basically like the same group of stairs. They were just mirrored, so I can have stairs like either these or like, you know, the other way around. And so I needed to manually, because it would generate some other kind of problems. I needed to manually, the same way as I did it before. In the more basic example, I just put them together, put them separately. Oh yeah, that's why I'm disallowing rules here, because I'm doing the double disallowance. I wanted these not to be able to connect. I didn't want these two not to be able to connect. I wanted within themselves to be able to connect, So that was the opposite way as I did with the example counterparts. I wanted so they don't connect only within each other, like within this group with this group. So I basically disallowed the behavior I wanted to allow, and these I allowed, but I put them I put them into like this is making like it was this is disallowed rules. I mark it as that. So I hope you can follow me with this, because I feel like that meme in front of that conspiracy theory board right now. But yeah, so I disallowed what I wanted, so I can filter out the things I actually wanted to disallow, basically. That was the thing. So that's how we do the opposite, unfriend the neighboring modules within the different groups, compared to counterparts where I wanted them to be friends. So, and I did a lot of stuff like that. These were for like so basically that's why I separated them in so many boxes. That's why I have them like color schemed, so I know which ones then are which, and so I can make special rules for every single like box from them, and so on and so on. And like I have so many of them because I have also 4 rotations, and I needed to. It was basically like a lot of copy pasting work, because if it works on this, I just then copied the whole chunk, and it's even looks the same, because like I literally just copy pasted and like rewrite the numbers to B's and the indexes to B's and C's and D's. So it's identical on all the sites. And in the end, I also wanted to, so these sites can, for example, no, this and this needs to be connected in this part, for example. So I wanted to make else. So I needed to. I never created rules like within every like within this whole thing. I created rules within this one rotation, and then I allowed only that these modules, these green ones, can connect to. I think it was the red edges. No, it was the orange. Yeah. So the orange are here, blue, for example, and yeah, this could connect, the else could connect to the other rotation of the stuff. So it's basically I needed to very carefully think what kind of rules I was generating, because there were so many of them. So yeah, you can try and replicate this, or you can just try this file and tell me how to do it better, because this was too much. But I really tried to like imitate Corbusier. That was my task, and that was quite complicated. And I hope it's uploaded, and you can have it if you want it. Probably Mike already downloaded it. Yeah, it's the file I'm housing. Yeah. So eventually I was able to come to a moment where I could check and see what's going on after these. I mean, I was checking like while I was doing that, but it took so much time. So it will take 30 seconds. Like every change I made, like it took 30 seconds to calculate, because imitating what already was is like in Monoceros is sometimes like doing like very specific thing you really want to do, and what you expect is always harder than just having fun with it and like look what it's gonna create itself. but I really wanted the stairs. And yeah, it created this. So basically, but I lot of subgroups of disallowed rules, and some rules were like maybe even explicit rules. And yeah, there are also like there is also a component called rule exclusivity, which you can find within rule. And rule exclusivity, it enforces the only one group of rules. But otherwise my setup is quite simple. It's just too big. But I do the same stuff over and over again, and it's I'm not trying to use as much components as possible, or as many features as possible. I try to keep it simple most of the time, and I used rule exclusivity for actually. I wonder myself, because I haven't opened it. I didn't want to see this file ever again. Oh, I'm so sorry. I think we somehow stopped the recording or everything. Hello?
No, I think it was just like some short. I don't know. I think you can continue. Just share the screen again and.
Oh, it happened to everyone. I thought my internet was. Yeah. I think my internet just went down for a little while.
But you can continue. It's
Okay, we are back. You know what happened to me? I have suddenly on my both devices, Zoom just switched off, and I didn't know when it happened. It just suddenly stopped. Yeah. Okay. So I am probably like boring also the Zoom, so I will keep it simple. I used it for something and I don't remember what, but I will try to remember it right now. Oh, that's the ground. I wanted this to always be on the ground. So if you remember the out rule, out layer, I made a rule that I actually pointed it out with actually this point, that this component, it's the lowest one. It's the one with the base also in the bottom. I wanted this to be always like down. If I didn't have it, it could float like up and down, and it wouldn't work. And it could also, since this one is it doesn't have any connector on the bottom, it could also be seen as indifferent, and it could be built on top of any roof. So I enforced this rule. So I created this rule by making points and copying it, and I created this rule like with the together with the out module. So with the out module, I didn't care that where is my connector, like if it's Z or plus Z, because this can only find the this rule from connector, it finds the opposite. So I just deconstructed the out module. I didn't care which connector is actually like in use or anything, and it found that all the plus Z component was connecting to the minus Z component of this bottom base and then I created the rule exclusivity, and I did it in the complete end. So I put all the rules, and it actually like deleted all the other rules. So it's similar than that disallow rules, but basically just deleted all the rules which were like somehow suggested from like the rules of indifference of every other, like it couldn't suddenly grow on top of the air, on top of empty. It could grow only on the bottom of my slots. So that was basically the first layer. And the second layer is so much simpler, but this one was just trying so hard to create something which was working, and it kind of was. And then I'm like, again, filtering it with elephant because I'm lazy to filter it myself. But I needed to keep my, I will call it out. I needed to keep my materials intact because I needed in the second phase, and I just baked this. And now I have this. I don't even know if like there were like so many solutions. I just had like successful random seed 12, so I put it there. But trust me, it creates like different stuff on different seeds. It just takes so much time if it actually finds something, because right now our new solver is actually doing also one thing. You put a seed which would be unsuccessful, and sometimes if you put like atoms a little bit higher than it's advised, it tries to search to the front or from that number. It tries to find, like, let's try just from fun. It tries to find for another successful fit seed. So I would put, I know the 13 will not be it. It will take a little while, and it will search now like what other seed could be possibly successful, and it actually goes and search like all the other. Okay. Oh yeah, and this is a funny thing. It didn't give me the seed like error from a number 13. The number 13 was not successful. It was searching like more, and it found that number 19 was successful, and it also thinks that 1923, I don't know on kind of what magic, maybe Jan will be, yeah, Jan is the only guy who knows how this magic, and Janči. We have the programmer and the boss. So they know the magic behind this, but somehow it can also find the next successful seeds. So if you don't want to waste so much time, if you have something heavy like this, you can just then you will know that 20 seconds wasn't the seed. 20 seconds would take a long time. I basically just made this, and I if I wasn't happy with the seed 19, I will basically, let me just put it here. Okay, so 19 was quite all right. There was something, but maybe 23 and 26, and it's gonna spend like take a little less time. So 23 was 19 was fine. 23 will hopefully take a little less time. And 23 is making some little interblock. And what about 26? Yeah, so it can help you, but it will not write you when it's successful. It will write you only when it's unsuccessful. So that's a bummer. That's why I write it down somewhere sometimes, like which ones are actually working. But to move towards the other, I think I copied it already. So I'm gonna move to the other one. I have two same windows, and I put it into a little simpler And this one I actually deleted so many of the modules I didn't use in this one because it wasn't necessary to overdo it. It was just a school project. I basically I will filter in the mesh so you can see what actual geometry was looking like. So basically, I just had I differentiated the connectors just on the shapes or how it looks like. So I didn't draw so many rooms. It always consisted of this is like half of the actual module. So this was the module of, I don't know, 1.8, I think. Oh, like this. Yeah, it was 1.8. So, but the height was probably 3.6, and I just literally I drew it so it doesn't grow up and down on the floors. It was indifferent in the floors beneath them, because I was sure that actually beneath them there is gonna be something, because the structure was also quite rigid before, and so I was sure that it will end up on the right position. So I didn't care if it didn't need to interfere in this level. So I just created rules within the plane, and some 2D rules, and this one has also some bathroom. And so basically I had a left side and the right side, and these couldn't connect to each other. These only could connect to these, and the second layer. So basically this I had some modules which could connect within themselves, and I'm missing the line here. Oh, no. So it also had a start, and it had a second layer and a third layer, and the third layer was optional, so it could grow like this. So that was quite simply put, because it was just 2D rules and just rules drawn based on the little edges according to this. So that was it. But the main thing was inside. That's this actually. Also, I will open the Grasshopper so you can see also what's happening inside there. And for just in case. Oh, but it actually will work because I don't have any slots now. Yeah, it's not happy because it doesn't have any slots, because I need to paste them. And if I will paste them right now, I hope it was at the right position. Yeah, I think so. It doesn't even matter that it's in the somehow interfering with it because it's a block. Oh yeah, it still is a block, like block instance, and the only thing I'm actually caring about is the colors. I was basically doing like this. I need to change this color to. Oh, I hope. Okay, let's see. I was like explode block. And now I exploded those blocks, and then I filtered, and I made a little contraption. I named it line element, doesn't matter, in and out. So it knows I separated the modules to in and out, and I will show in like a little second what I mean. Ah. So I'm gonna this one was faster. Okay. Select objects I wanted. Okay, I selected all the outs, put them here, so they are happy here. And the in, I think I will have a problem, but I can solve it like this because they have the same color. But yeah, and now I just separated inside and outside. And now they are here, and I already have the slots. I'm just gonna hide them. So this the structure itself, I could actually also put away these helping, yeah, like this. So I have only the structure, and this tell to Rhino to like fix their interface, because every time I click accidentally on tool, then I need to click it back. So I have these filtered, and now I'm creating slots based on in and out. And I scaled them because they, I don't know why, but I just had them like this, maybe because of the picture. Yeah, and I just scaled the duplicates, because if you will accidentally have one at the same position box when you manually do it from Rhino and then you import it, it will not work. You need to make sure that they are not overlapping against each other, and I will just demonstrate it by like what will it tell you. And they were overlapping, but I just called like I deleted some of them. But if I would do this, it would be very unhappy. And this was also from the previous version, so I'm lucky that it actually works. And it wasn't happy. So even if you have like 1 millimeter problem, like it's better not to create boxes from Rhino. But this one was actually kind of, I consider it quite clean. So it was low risk. So yeah, I created the in and out. So I have like slot modules which followed the inside and the outside. So everything around it was like this was inside. So then I made some little the previous I showed you this inside, which could connect only doors. This I consider doors. This I considered as doors, but there was actually a wall. And these were also the doors, but they could continue to the other side, to these corners. It's better in this diagram. It could connect to the corners, and it could go around the corner and stuff. So yeah, it went. It could be either that, or it could be like the empty, but I needed the empty to mean something, because otherwise it could connect to the actual empty. So I needed to have some kind of connector there. So I just put some kind of connector, so every other component has a connection to inside. So I was very much controlling what's ending. Maybe I just over control it, but what's inside. I wanted to have a control of what's actually inside. What's facing the wall inside. So I did it like that, and it's quite big, but it's again it was just a copy paste. I wanted to be sure every module had like its separate box, just because I was putting lot of layers and like a lot of windows and stuff like that. So I needed the properties, the render properties to stay. So I couldn't rotate them. So every single one of them is just copy pasted from Rhino, and that's why there's so much mess. But in the end, it should be quite quick. Yeah, and it found a solution, and I didn't put any additional rules, just the rules of a join, basically. Like, so if I know that this I want to be joining only with this group, I just hand drawn the connector and made the opposite connector for that. So that was my control I enforced in this project. And yeah, so, and the other layer was the same. I just don't have it in this file because that was calculating super much, because it was tiny boxes. It was not even hard on to calculate in like Monoceros itself. It was just heavy. It was like millions of boxes, like so many boxes. So this was like one of so many ways how to make housing. And inside you can now see that there are the hallways, and they can also mean something. You know the position of doors right now already. You can actually not put it in the middle as me, but you can put it on the floor, and you can use it as for people to generate people when you are rendering it. Or that was my two uses. I just came to my mind. And you could bake it and internalize now the geometry, and later edit, as Kristýna showed in real life. If it's like too heavy, you could edit it like post process, like you can just use slots, and you can already solve Monoceros internalize. You could put it here instead of actual stuff. And now you can just disallow this, and you still have the solution. And if I would, for example, this takes time. The recalculation of that I hit, or that I did something. Oh no, my computer. No, okay, it's fine. If this wasn't the mesh yet, and if it was like something alive, I would be able to. I will just demonstrate, and probably that's gonna be enough for demonstration. There should be something missing. I will just delete it. Everyone, I should have deleted this. In the corners. And if you would edit it somehow, and if it was in the mesh, it's actually visible, like how much you can change, like already, like you can use it basically as a beam. Like at this point, like you can change the size of windows and like stuff like that. It's probably not that visible because I have a terrible transparency, but yeah. Okay, yeah, it's somehow visible, somewhat. That I can just now destroy my precious object just by deleting, just by destruction. And this is a very nice time for my keyboard to stop working, but yeah, you get the idea, I hope. And that's probably it. And I saw something in chat, and okay, it was above my screen. And so yeah, that's one of the demonstrations on how can you make something actually if I would make now a section, maybe that was the most important thing for me at that point, that I can make sections and it works and it doesn't interfere with each other. And if you will find any mistake, I will just commit some harakiri, because this was, yeah, it was working. And if I had more time, I would be able to like make more like fancy buildings. I didn't have to make it as a actual as actual capsule, but it could be having geometry like which incorporated like the same structure, like it could be part of this original structure, and it would just switch up and down and just connect to each other like normally. I just used it as a capsules, and every single one of them had some kind of bathroom and everything, just because I had very, very simple rules and simple floor of like just very little modules. But I think if I left the base and just edit it, like add it on top of this, it has potential to create something more interesting than just some this. Yeah, so it's 22:03 in my hemisphere, and I think we just made it in time.
Incredible, like perfectly on time.
Yeah, almost perfectly, 3 minutes.
Nice.
Yeah.
Like
This- Go ahead.
So that was it. If you
did we have some bonus examples? I don't know if you would like to stay here a little bit longer, or leave
can
a
talk.
space for Q&As.
It's up to you. We can say. Up to you.
Well, I can show it because it's in a files. Let's go. Okay.
Let's
It's
go.
just more or less fun. So stop share the screen.
Yeah, I
Michaela.
will try to. Yeah, perfect.
And it's about this file, because this kangaroo algorithm is my favorite. I also made like a bench and more stuff like this. I don't know, sometimes you just something and then you repeat it and combine it with everything and overuse it. So I think now I overused this pattern, and even I connected it with Monoceros. And so, as I said, it's like more fun thing. You can find it in files, and also we had some parallel discussion that I think the true potential of Monoceros is to combine it with something like better connected with WASP. I'm really curious what we will find out and how it will work. This works like I will make like some 2D outline. Okay, this 2D outline. It will count the Monoceros result. Where is it? It's here. Yeah, and the inputs are those simple 2D geometries. It's like okay, it's only curves, like a simple and more dense. It's because of those patterns started to be like they are nice, but it's quite rigid. So of course there is more way how to get rid of this rigidness, that you can draw it in different way the line and something, but I use it with Monoceros because Monoceros is great. And yeah, I created simple rules and generate some pattern. Okay, this I have to. Yeah, we need only one polyline for kangaroo works, and then we can plug it in this part. It's behind the Monoceros. The Monoceros result is here, and then we will do some grasshopper and put it inside of this. And now we will see what it happened. Woohoo! And the point was now I don't have any attractor, but I think the true potential is that I will, for example, allow only very dense modules to be here. So then I will get rid of the rigidness, because here it will be more dense, here it will be less dense. And theoretically, I will do it in this construct slot, because as I have it for the outer boundary, so I can have it I can separate this construct slot and allow only in some parts to, for example, like the dense one, and the other parts can have both, and some parts can have only like the straight one. So I can manage the density, and then I can make something with it. And I don't know, I like this algorithm maybe because it's moving or because it's continuous. But I just wanted to show you that you can use the result for whatever you want. And sometimes it can be interesting. And then you can make a bench or wall or something like that because of this. Yeah, because this bench, it's a little bit, how to say it politely, it's too rigid. So I was thinking how to, not to draw it, but how to make it a little bit less rigid. So this can be one of the ways. Well, and for me, it's like everything you can play. It's quite fun with it. And I'm thinking if I would like to say you something more. Like, thank you that you, how many people? 27. It's nice. And
Everyone's at
yeah,
the beach.
I think that's only people that were left. Like we destroyed the rest of
remember.
them.
It's less than a quarter of people. That's
Okay,
Yes.
that worked.
They eventually left the game.
Okay, this is really rigid, but well, I have to. It was just idea I made like a few days ago, so this is a very white bonus example that I should work with it more. And actually, we will be really pleased if you will use this space of Miro and leave us some comments or something what you created, because maybe you already see it, but this project Monoceros is about, I don't know, connecting projects, connecting people, and creating new ideas, because as Michaela mentioned, we are not doing it for like money or because it's our job or something. We are like enthusiasts and it makes sense for us. And, we are like, we like doing crazy stuff and programming them. And then we like to make toys for kids, for example, or some crazy diploma projects. So it will be for us very interesting if you can join us and give us feedback, or if you will play with the examples later and show and create something new. You can tag us in your Instagram stories, or you can put it here, or send us email. It will be like really helpful, and we will be happy that somebody cares.
Miro, I now I'm just looking that I just shared the viewing like Miro board, so
we will
nobody
join.
can nobody can put anything, but anyone can invite team to a board and just go crazy if you want. I want to see if they're the person who was here with the wasp. I want to see it in Miro. I really want to see it.
I already have files.
You already have files. Just okay. I will just put it in chat. The new link. Or tag us on Instagram or anywhere. We're gonna be happy to see anything. Yeah, we're done. Finally.
Thank you.
We didn't go so overboard. I thought from the beginning it seemed like we're gonna just stand here the whole like session. Yeah.
Thank you. It was very, very good. Does anyone else have any questions before we go? Or if anyone's feeling like they want to ask a question on camera or microphone, you can raise your hand. Or you can just ask a question in chat. Let us know if you have any last questions. I guess not. You've answered all their questions as they went, so that was good.
I think we did a lot of chat in between, so where does go? Let's go from here. Everywhere, I hope. I don't know. Places.
Yeah. I mean, yeah, it's gonna keep growing, I guess.
I hope so, yeah.
Is Pro public yet? Like, can people
No.
buy it already?
Mm-mm.
I think you can buy it through Patreon.
Oh yeah.
I see.
Like it's not free. It's yeah.
Do you have the link to that?
No, Kristýna, if you are looking for something new on that web, I have a summer vacation quest to update it since last year, so there's not gonna be any other new information like since Monoceros the first release.
Thinking about the Patreon page because I saw it
No,
somewhere, but I don't know where.
Jan had it, but Jan only shared it. He didn't even put it. He didn't even have the time to put it. Oh, by the way, this is
Yeah,
this is our
yeah.
notice board.
I had
we
it
were doing
prepared
this
here
stuff.
because
Yeah,
I think it's not a bad approach to iterate things like create corridors, then create something
Similar, like-
more, and continue, not try to solve everything in one stage, because
That
then
was
your
also the
computer will burn
example.
down, and it can be quite more interesting. Like this is our crazy mirror. Here is the this is a simple one. I know you showed, but just
Yeah.
I agree with you that I think this is a good approach to make more monoceroses behind each other.
Oh, the answer to ask that's I don't know. There is no average user. I mean, the point is to become a good user, right? So I think anyone.
Thank you, guys. Maybe we eventually will find a way how to make like a tool from Monoceros to like for architecture. That's also like when I'm searching for all the stuff, I'm also filtrating like what you don't need maybe, and maybe there was the Monoceros is going. I'm going to my doctor right now about like it's called about modularity something. I don't know. I haven't written it yet, so I don't know what's gonna be like there in next 3 years. But I want to maybe make some sub tool like for like just for architects or some like like.
I feel it's already applicable to architecture
Right.
more than anything else. I mean, it's
It
a
could
space
branch,
planning tool, if anything, right? I mean,
yeah.
in the simplest sense. In the most complex sense, of course, it can be like super complex, like
Oliver, that's why
solving all the materials and architecture. But yeah, I mean, I don't see the difference between architecture and a game architecture. It's
yeah. And Oliver, that was the reason why I used the modular design this utopian arc dream. That's why I use the Kurokawa and stuff like that, because like I wanted to show like, okay, and now we can do it. Yeah, so thank you everyone. I will stop talking. Somebody stop me, please.
We will shut you
That's
down.
okay. That's okay.
Just
Well,
keep me
thank
on.
you, everyone.
Okay, we can continue the discussion on some platforms. Like there are plenty of platforms where we can discuss, like Grasshopper 3D or under Monoceros website, or here there are some people already putting some arguments. It's about Monoceros basic, but whatever. Or you can send us message to Instagram or email. We'll be like really happy if you will communicate with us.
Great. Yeah, well, thank you so much. Thank you everyone for joining. Just a reminder, there's also a webinar tomorrow with Adidas Maya with Alexander Bersak from Heatherwood Studio. More about kind of fashion and yeah. Recording will be sent when it's done. I mean, you all know that information. Great. Thank you so much for your time as well. And yeah, until next time.
Yeah, see you next time.
Bye bye.